Hey everybody, how are you? You guys caught me as I was finishing the last of my little macadamia nuts, sorry. Hope you're doing well. Good morning. It's Sunday. That only means one thing, and that means that we are doing our tutorial session. We are going to continue our series, which by the way, I'm really happy with the way this series has been going. I think it's going to be a great series. But we are doing a series on creating a data science project from beginning to end. And today is part 7, I believe. And we've been moving along. We've been doing a really good job of moving this project along. And we're going to make some decisions today. We're going to be doing a lot of coding today. We're going to be just doing a lot of things overall today. It's going to be it's going to be a working session, right? Like we are in the thick of things right now. This is the work of a data scientist. So we're going to get a lot of that today. So I'm really looking forward to today's session. I had a really good time putting the materials together. I put the materials together yesterday. And then I woke up this morning to put them, kind of put the final touches on them. I always like to look at them after a couple hours, right? So I think we're going to have a good time. And it's going to be just a very working session today. I mean, that's really kind of like the best way I can put it. Because, as you guys know, we are in this fictional project where we have a client, a finance company that's looking for, alpha farming opportunities. And we haven't really spoken to the client since we signed the contract because there's nothing really to show yet, right? There's not a whole lot to say, not a lot of concrete stuff for us to do a demo or some sort of conversation with them, right? We're not quite there yet, but we will be, right? So that's the part that I'm really looking forward to today because I think, we are at that stage where we got to start moving forward. We got to start, kind of making some decisions, right? So that's what we're going to do today. And I think it's going to make for a really good session. So for those of you that are joining us that are new, welcome. That still happens. I still get new users on YouTube, still get new users on Instagram. So really grateful for you to be here. You're welcome to participate as much as you'd like. We usually do a lot of back and forth in our Sunday tutorials. So you're welcome to contribute as much as you'd like, as much as you feel comfortable. We try to not have a judgmental atmosphere, so we try to kind of keep our minds open to other people's thoughts and ideas because that's an important part of science too, right? So I'm really happy to have you here. Really happy that we're going to spend some time together. We're going to be together, I think, for a couple hours today. I think it's going to be a little bit of my gut tells you it's going to be a little bit of a longer session. But we'll see. We'll see where we end up. If you're joining us on Instagram, welcome. You're welcome to stay on Instagram. I've also included the link for my YouTube channel so that you can view there. Some people like it a little better on widescreen. You're welcome to join us there. Chowdhury on Instagram is asking YouTube channel names. So the YouTube channel name is all my names are always Data Science with Dennis. So you can search for Data Science with Dennis and you'll see the live stream link there and you can click on that. Okay. All right. So in my chat already, feel free to fill up my chat if you want to say hello or we'll just get started. It really just depends. At the very top today, Osama, you're the first person here today. Really appreciate you. How are you, my friend? Hope you're doing well out there in Satat, Morocco. Hope you and your family are well. Thanks for being here. Such a great supporter. Thank you so much. Speaking of great supporters, hey Rex, how are you? Rex, really appreciate you being here. Thank you for being one of my moderators. Hope you're doing well out there in New York City. Matt, how are you? Matt says, happy Sunday, everyone. Matt, I get so encouraged when people come back. I think yesterday was one of your first days, or at least one of your first days participating. So thank you for coming back. Really appreciate you. Really glad you're here. I'm sorry, I don't know. I can't pronounce the name. My Arabic is not that good. But thank you so much for joining us over on X. If you'd like to tell us your name or where you're from, introduce yourself. It's up to you. Starry Vibes, our good friend Starry Vibes says, "Hello, sir. Hope you're doing well." Thank you, Starry Vibes. I'm doing very well. Hope you are doing. Hope. Oh gosh, I can't talk, guys. Hope you're doing well too. You're such a great supporter. Really appreciate you coming back. So, really looking forward to today's session. I know you said you were looking at today's too, and I think it's going to be a good one because a lot of data science work today. Okay. AJ, our good friend AJ from Berlin says, "Hey Dennis, looking forward to today's session." Yeah, me too, AJ. Me too. I'm excited. A couple things we got to tackle today, but I'm excited. It's going to be a good one. Okay, so Matt says it was my first non-lurking day. Well, thanks for participating, Matt. Really appreciate you. And Matt, I know we also have a call scheduled, so thank you for that. I look forward to that on Wednesday. Look forward to our discussion there. What are you teach exactly, R or Python? Ooh. Well, I don't really teach either one of those. I teach data science, right? R and Python are just tools for data science, but I don't think of myself at all as a Python or R teacher. And those aren't the only options for data science instruction, right? So yeah, I don't teach either one of those, my friend. I teach data science. We're going to do a lot of work today in code, right? We're going to use our toolbox of code today. Lots of that today. Yeah, but it's data science is what we're here for. So really appreciate you joining in. I'm pretty sure it's your first time. But we're going to learn data science, and right now we're going to learn, the process of putting a project together. But specifically today, we're going to focus on model selection and running our experiments with our models. So you're welcome to stay. Appreciate you following. Ruben, I think this is your first time. Greetings from LA. Been following you for a while. Thanks for always putting out great content. I appreciate that, Ruben. Thank you. Ruben, and I appreciate that you're taking the time to, come out of the shadows and introduce yourself. Thank you so much for that. I'm glad you're here. Hope you're doing well in LA. I grew up in the LA area. I'm going to be out there in 2 weeks, I guess, something like that. I'm going to be out there in 2-3 weeks. Happy Sunday, Dennis and everyone. I'm so happy to be here. Yeah, Joseph, my good friend Joseph. How are you, my friend? Hope you're doing well out there. Thank you for coming, and thanks for being one of the moderators. Hope you're doing well. Peter on YouTube, I think this is your first time. Which company do you work? Which company do I work for? You're looking at it. I work for this guy. No more companies for me. I'm self-employed, my friend. Well, what are you talking about? Which company do you work? I have a long work history. I've worked for some of the largest companies in the world. I've flown all around the world doing all kinds of consulting contracts. But I work for this guy. This is what I do. What are you talking about, man? Like, this is my company. But yeah, I mean, data science with Dennis is an LLC. I'm incorporated. It's my own business. I do a lot of content, obviously, but I also have consulting clients. I also have my own personal interests that I pursue. I only do things that make me happy, guys. That's the whole purpose, right? That's why I'm here. And I want to help the future generation of data scientists, right? That's really, why I do this. But yeah, I work for this guy. Starry Vibes says, LOL. I think you're referring to the working comment, but yeah, just, like, this is the job. Like, you guys think these streams just come together? Like, I put a lot of work into this stuff. Joseph says, doing well, Dennis. Good, Joseph. Glad to hear it. Peter says you like so. Well, thank you, Peter. And we appreciate you being here. Like I said, I think it's your first time, so thanks for joining in. Matt says, some say Dennis has the best boss at the moment. What's that saying? The pay isn't great, but job satisfaction is high, right? So yeah, the boss is all right. He lets me go hiking and do whatever and play golf whenever I want. But this stuff is not easy, guys. Like, content creation is probably like one of the hardest jobs I've ever had to work at. Now, there was a big learning curve to start, right? I had to learn all the tools and all the platforms because I didn't know what a short was or a reel was or the difference, and and what's an Instagram post versus a reel. I didn't know all that. So, it was a big learning curve, but now that I got my tools and my process, it's a little easier. But this is not easy, guys. What's funny too is I'm going to be releasing very soon a blooper video, like a behind the scenes video, because I'm going to be approaching 100K on YouTube. So I made this little blooper video. Like, even the stuff behind me, guys, like this, I designed all this. Like, I started in a completely empty room with terrible lighting and a terrible microphone, right? So like, this is hard. This this is work. Trust me on that. Rex says ultimate goal. Rex, you're a smart guy. You can get there. You gotta build up some street cred from the clients and the companies you work for, obviously, right? But you can get there, my friend. You're a smart guy. Peter says because I'm getting inspiration for you, or inspiration from you. Well, thank you. I appreciate that. Yeah, I mean, if it inspires you in some way, great. What I'm really trying to do, like I said, is create the next generation of data scientists, right? Help the next generation. Just like an older doctor trains a younger doctor, right? I'm an old guy, so I'm here to train the newer people, like the rest of you, right? Leo, our good friend Leo, such a great supporter. Really appreciate you, Leo. Greetings from NYC. Hope you're doing well out there in Fiddy there, Leo. Glad you're here, and we're gonna have a long session today, Leo. So glad you're here. Litigan over on Kick. Wow, look at that. We're having all the platforms chime in today. The only one LinkedIn, right? Nobody chats on LinkedIn. But wow, we have all the platforms today: Kick, YouTube, Twitch, X, and Instagram. So good job, guys. Litigan, if you want to let us know your name, feel free to contribute. Ruben says, do you apply data science on your socials, like applying models on your social analytics? Great question, Ruben. Not yet. I make basic projections, like on how I'm trending. Like, for example, like I said, I'm going to hit 100K, and my trending shows that it's going to happen like Wednesday or Thursday, something around that line. So I do basic analytics like that, but nothing like deep or exciting. I should, perhaps I should. Because I do want to study some more of my most subscribed content, right? Because the content that you put out there versus the content that people subscribe to are two completely different things, right? So I might do some things like that. But for me, for social media, I think it's just been more about coming up with my own ideas and my own approaches to things, right? Listening to people out there who are putting out, really good, really solid information. And then also just trying different things on my own. Just trying different things. But yeah, Ruben, at some point, maybe I will. I don't know. Maybe it'd be fun to release that data set to all of you guys, and then you can tell me, right? Maybe I could do that. Maybe that could be fun, right? Just give you guys my entire data set, and then you guys can tell me something about it. That could be fun. That's bad OPSEC. Litigant, sorry, don't know what you're referring to. Let us know more about you. Don't know which portion that comment was aimed at. The chat moves fast here, litigants. You got to keep up here. All right, guys. So last call for introductions or hellos or any other, smaller questions. But otherwise, I kind of want to get started because my gut tells me that we're going to have a little bit of a longer session today. But yeah, so last call for questions. Otherwise, we're going to get going. Lakshmi, our good friend Lakshmi. Morning, Dennis and all. Hope everyone is doing good. Lakshmi, so good to see you. When I think of the people who love the Sunday sessions and come on Sundays, I think of you, Lakshmi, because I know you're such a big supporter. So thanks so much for being here. It's going to be a good session. So glad you made it. Hope you're doing well out there. I know I know you told us it's about dinner time for you. So hopefully you got a good dinner and you're ready to learn, because I think we're going to do a lot of stuff today. I got my water ready, so let's see where we end up, guys. All right, so I'm going to keep an eye on the chat, if anybody else wants to introduce themselves. But I'm also going to start getting things ready here for the classroom. So give me just a second. Good. Refresh. Yeah. Okay. That right? What else do I need? I think that's all I need for now. Okay, so part 7. I can't believe we've made it this far. The focus of today is going to be on the actual modeling exercises that we need in order to develop a more mature data science project. I know that many of you in the chat have been following along for all of the series. So if you think about everything we've done, so far, everything we've done have been kind of scoping exercises, right? We had some good ideas. We had a lot of good discussion. We scoped out a couple things. We used a couple libraries. I think we have like 3 or 4 different code files, right? Some data files. So it's been really fun, but we haven't really picked a concrete direction. We haven't gotten to the concrete side of the model selection, right? So remembering our methodology, right? So I think it was our new friend on Twitter, on X, who was asking about, well, are we learning R or Python today? Well, neither, right? What we're really learning is this, the chart that's up on the screen, right? Data science is a process. It's not a tool, it's not Python, it's not pandas, it's not any of that. It's a process. So we've been following this methodology and we've been doing pretty good. But I think it's time for us to start talking more about the model design and the interpret results. We're going to be in this loop here for a little while. And for most of today, maybe even into next week, I'm not sure. But we need to start focusing on, okay, well, we're beyond the idea stage. We have a pretty good idea of what our data is going to look like. We have a good source for our data. So now let's start talking about the model design and interpreting these results. And I say that not just because I want to move the entire series along, but because at some point, you can't get caught up in too many ideas. At some point, you as a team or maybe, you as a data science leader, you have to make a decision and say, hey, this is the direction that we're headed in, right? We did our scoping, we did our due diligence, we got a little bit of research behind us, and this is the direction that we need to go. So let's move the project along, right? That's a healthy thing. I call it, kind of like planting a flag, right? Where somebody has to step up and say, here, this is what we're doing. This is the date we're doing it by. This is the deadline we're giving ourselves or whatever the case may be. Let's all, try to pull on the same rope and go in this direction. So we're going to be doing a little bit of that today. So that means that we actually are going to put together some of that modeling code, some of that, doing some of that interpretation, right? And again, I know a lot of you have been attending. So just to be 100% clear, I don't want anyone to think that what we've been doing has been modeling code. We've done pretty good exploration code, but I don't see us as having done modeling just yet. We're not quite there yet, right? So that's where I'm kind of hoping that we're going to end up today, where we're going to, you are going to be able to see a distinct difference between what we've been doing so far versus like what and how a model actually comes together. Okay. So Lakshmi says, yes, all set for the next 3 hours. I think it might be 3 hours today, Lakshmi. We'll see. Pratik, welcome. I'm glad you're here. I think it's your first time. Thank you so much. I'm Pratik, working as a data scientist. You're in the right place, Pratik. You're among good company, so thanks for being here. Yassine says, hello, sir. Yassine from Tangier, Morocco. My good friend Yassine, how are you, my friend? Hope you're doing well. Hope everything's good in Tangier. Thanks for being here. All right, so model selection is really basic. It comes down to what are the experiments that you're going to run, and then how do you evaluate those results? What did you learn from the experiments, right? Putting together the experiments, and then what did you learn from them? Two completely separate exercises, all in the same stage, right? Or the same phase of your project, right? And that's kind of like where we're going to be focused today. So, quick summary, right? Where do we stand? We have 3 good ideas that have been scoped out. We talked about doing new sentiment analysis. We talked about efficient frontier theory. And also in the parentheses there, remember that we also talked about how that's a lazy loader approach, right? And then the third one is time series forecasting, right? What can the past tell us about the future forecast for a particular investment? Right? So I think those are 3 really solid ideas. We've done a good amount of research into those ideas. We have some code. We've looked at some visualizations, and things are looking up, right? So we probably can't proceed with all 3 ideas. So let's make some solid decisions on which direction we're headed. We have to, as I write there, we have to cut down the list at some point, right? Because otherwise, we'd never meet the client deadlines or your team deadlines, right? So you have to make some decisions at some point. So what we're going to go through is something known that you might hear referred to as a champion model process. There's other names, other variations, but generally speaking, it's known as the champion model process. And I know that it sounds, fancy or intimidating, but I've given you a basic outline there, right? Start with a baseline value for accuracy or some other metric that you want to use. Design and run your data experiments to try to improve that number, and then repeat as necessary. In theory, you would repeat it until you found the best model possible, but a lot of times you're going to have time constraints. So you're trying to find the best model possible or as much time that you can that is allowed, right? But that's basically your goals here. That's basically what a champion model process is. You're just going to always hold a baseline number and say, I know that if I use this model with these parameters, this is the metric I can get to. Can I improve on that metric? And that's it. That's all you're trying to find out. And that metric doesn't care whether you're using a neural network or regression or clustering or whatever. That's kind of the process. That's where the experimentation comes in. But you're always comparing yourself back to your baseline number. And by the way, I realize that I shouldn't have used accuracy here. I'm using accuracy here as a general word for metric because you can use other metrics than accuracy or precision or recall, or sometimes you want to optimize for precision or recall, as we've spoken in other sessions, right? So this was actually a poor selection of words on my part, because you can basically think of any metric, whatever the metric is that you want to use for your particular situation. Okay? So how do we actually do that? Well, first part of it is you got to design experiments, right? You got to have something to test with. If there's nothing to test with, then there's no experiments, right? So I've also, in the parentheses next to each of these, I've kind of also given you like the different the different soft skills that a data scientist needs for each of these, right? So what do you need to design experience? Well, you need creativity, right? You kind of need to think a little bit outside the box. The answers aren't always there. But basically, the way I express this to the people that work for me is I tell them, we always need to have levers to pull, right? Like you got to have levers to pull on the machine, otherwise you're dead, right? You're not you're not dead until you run out of levers to pull. But if there is none, then you're not really modeling, right? You're not experimenting. So usually those levers come in the form of hyperparameters, right? What are the hyperparameters that you are putting in? What is a reasonable range of values for those hyperparameters? And then how can you use those hyperparameters in order to run code? Because when you run that code, that's you executing the experiments, right? And that kind of, well, actually, before we leave design experiments, the second part is not all hyperparameters or not all testing items are always going to be clear to you. It's going to require some creativity. So you should always ask yourself, what else can we use for testing? What are some of the other elements that I can test on? Maybe it's different cuts of data, right? Does a model behave differently if you use 1 year's of data but not another year's of data? Right? Maybe the model doesn't hold, or maybe it doesn't hold across different customer segments, right? Like if you're working for like some sort of commercial, like retail operation, right? Maybe some models are good for some customer segments, but not others. Maybe some are good for some geographies and not others. You have to ask those questions because those are experiments, right? If you say, hey, I want to go into modeling, but I also want to break out by continent, right? North America, South America, Europe, Africa. That in itself is an experiment. Maybe a model works in Western Europe, but it doesn't work in South America. You know, vis-a-vis the data you're putting in, right? So these levers that I'm suggesting to you aren't always just going to be like a list of hyperparameters. They're not always going to be obvious. That's where your creativity comes in, okay? So keep that in mind. All right, so the next part is the modeling skills, running experiments. What is the code you need? And then what are the resources you need to run that code? And by resources, I usually mean time and processing power, right? Because you are the human resource. You are the data scientist that produces that code, right? So here, the soft skill is the modeling skills. Basically, you know, if I, Dennis, am the data scientist assigned to this, then the correlation, the biggest constraint is what I meant to say. The biggest constraint on that process is, well, how many models does Dennis know, right? You know, obviously models that fit the data, right? But it's dependent on my skill, right? My modeling skills, how many models I know, and how proficient I am at writing that code is the constraint here. So that's like the skill that you as an individual bring to this phase, right? If you only know 10 models, then you're not testing more than 10 models, right? So, but that's the next part of the champion model process. I know my hyperparameters. I came up with some experiments. Now I actually got to run the experiments. I got to create the code to run those experiments, right? And then I also got to make sure I have appropriate processing power to handle all of that. Okay? Third thing you need to do is to keep organized records of all your results. And this is you working as a scientist, essentially, right? Being an organized scientist. Generally speaking, that means we're going to create a report, right? We want some sort of output that we can read. And then within that output, when I see my results, I want to know what hyperparameters or what test ran well, right? What test and the inputs to that test gave me the best results or gave me that champion model. Because that's what you're looking for, right? You're basically looking for that combination of my data, my model, and the hyperparameter inputs that gave me my best metric. The best metric that I'm measuring for in this project, right? I mean, that's the gold, right? That's when you've struck gold, when you can get to that. When you can say, I know that if I use this model with these inputs, I'm going to get a I'm going to get an ideal precision rate of X. Like that's the goal, that you're done when you do that, right? So you got to have a certain amount of organization where you put things together and say, okay, yeah, I'm gonna do this deep search of hyperparameters, and I'm gonna start it on a Friday afternoon before I leave the office, and on Monday I'm gonna come back to a nice report that's going to tell me how everything did and what some of the better results were. That's essentially like the work of a data scientist. Like this is the special skills that you're adding to the to your overall organization or your function and all that. Okay. And then finally, you're going to take those results and you're going to compare against the baseline. And you're also going to make sure that you save the model that improves the baseline. Right? Because that way you're saying, okay, here is the model in already a saved state. Now, and remember, we talked about this, right? You can only do that for models that actually have a fit function. You're not going to be able to do that for lazy loaders. But but for both sides, you're going to want to save the hyperparameters, and you can know and say, here's the combination that I need in order to run the best model possible, given my data, given the problem that's in front of me. And that's it. That's a champion model process. And we're just going to repeat this over and over again, as much as resources and time allow, and as much as it keeps on improving our baseline, right? Because we're always going to hold that baseline number and say, did we do better? Did we progress more on the scale of that metric? Whatever that metric may be, right? That's really just the ultimate question that we're asking ourselves over and over and over again. Ideally, you're always improving with every experiment. That doesn't always happen. Ideally, you have enough time to run as many experiments as you want. That doesn't always happen. But I'm just describing it to you guys from an idealized data science perspective, because this is the work of a data scientist. Okay? So that's really kind of what we're going to cover today. We're going to cover how we're going to design these experiments, how we're going to run them, how we're going to keep ourselves organized, and then how we're going to just compare those results against the baseline. That's ultimately what we want to do. That's kind of like the goal for today. All right. Manoj says, hello, sir. Manoj from Bangalore. Manoj, so glad that you're here. Hope you're doing well in Bangalore. I hope you got a lot of time today, Manoj, because I think we're going to be here a while. All right. So we got to make some decisions, right? For the interest of moving this series along and keeping ourselves, moving along the methodology process, I think we're going to only focus on two of these models. We're going to focus on the time series forecasting, and we're going to focus on the efficient frontier. We're going to do those two because, one, I think it's a good contrast between a lazy loader versus a fit model. I think that's really important, that we're going to, a really important aspect for us to look at. And also, I had some concerns around the news sentiment about the quality of the data. As I mentioned to you before, because we were using a free API, we weren't getting the full article. We were only getting like the first 200 characters or something like that. We were getting partial articles, and I don't think we could have gotten full articles in a quick way or in a cheap way, right? I think that would require having to go to like a paid API or something. So for those reasons, I, the chief data scientist, and making the decision that we're going to pursue efficient frontier and time series forecasting. And as before, we're going to continue to use our AI first approach to running the champion model process, right? We do not write code ourselves. We have an employee available. The employee's name is ChatGPT, and we're going to rely on it to help us with the code. Okay? That's really kind of the direction that I want us to go today. So we're going to work on these. and we're specifically going to work through the champion model process, the champion model search. All right. So I know I covered a lot. Any questions, any thoughts, go ahead and put them in the chat. But otherwise, I'm going to start bringing up our code. So I know we got a couple new people. So I just will reemphasize, professional data science is not done in notebooks. We should be trying to produce Python scripts and programs. And that's essentially what we're gonna do today, right? We're gonna focus on writing the best code we can, the most professional code we can, and then kind of going from there. And let me know if you guys need me to make anything bigger on the screen. But we have our terminal, and then we have our Visual Studio Code. And I think we're ready to pick up where we started. So I want to focus on the time series analysis today, because the time series analysis does use a fit function, which means that we can have a fitted model that we can save. So I think that just helps us maintain things a little bit more sequential in the way that I want to present them for this series. Okay. So we're going to focus on time series. If you haven't attended before, specifically, we're using the Profit library from Meta for our time series analysis. So we're going to be doing quite a bit of work with that function right now. Oh, with that library today. All right. Okay. So as I mentioned before, we've been doing explorations, kind of like proof of concepts, working with different pieces of data, right? Which is great. But right now, we're getting into a little bit more of a formal stage in our progress, in our development. Okay? We have a couple of files, and this is where they're located. Is anybody else uncomfortable with how messy our files are? This is something that's very common, where you kind of get started in a project and you start working on different things, and oh, I got this idea, I pulled this code off this other website, and you start to get a messy folder structure. And that may be okay if you're in the early stages, exploration, not every project works out. But if you're going to have a professional view on data science, you also have to maintain your code in a professional way. So I want us to start right now by doing some cleanup. And in that cleanup, we might also find some references to the champion model process, right? Because I think that's going to help us kind of have a different mindset to the things that we're doing. Okay? So let's start with that. I basically have a general code folder that's kind of for the project, right? The entire project is in this code folder. So that's going to be our root. I have no problems with the way that's named. I also have a data folder. I created that earlier in this series, but we didn't really use it. But it's always helpful to have a dedicated data folder where all your data is going to go. So let's go ahead and make that our first change. We have a bunch of these CSV files. We're going to put those in the data folder, right? Anything that's CSV, we're going to move to the data folder. So you might remember that we tried a variety of ticker symbols. We've been looking at Microsoft, Gold, Google, Ford, a couple others. But if we're going to be, a better organized data scientist, we need to put them all in their dedicated data folder. A quick word about data folders. Sometimes you might find it beneficial within your data folder to also maintain another folder or two folders, raw data and transformed data. So your raw data is exactly what it sounds like. It's whatever data you directly downloaded, right? It's completely fresh, untouched, unmodified. So that raw data always serves as kind of like your standard or your master copy, right? You can always go back to an untouched data set. And then in your transformed folder is where you would maintain the data that's been enriched, that you've done your feature engineering, you've done your NA searches and and your null searches and things like that. And then you would be modeling from your transformed data, right? Your raw data is never touched, never used for modeling. You're going to always model from your transformed data because that should be kind of like your gold master for modeling. We don't have that in this scenario because we know that Meta's profit uses just two inputs, right? There's really not a lot of need for data enrichment. But just so you guys know, there are times when you're going to want to create subfolders within your data. All right. So another folder we need. Oh, wait, I'm sorry. We still have some more CSVs. Okay. So our data folder, one more. So our data folder now has all our data. And in our root, we have these different files, right? And that's okay. But we probably want to do something with those also. So as I mentioned before, we haven't really done modeling. We've done explorations. So I'm comfortable putting this in an explorations folder, right? So let's create that. We're going to move all of our Py files or all of our Python files into our explorations folder because we know that's what we basically have done, right? So now in our root, we only have two folders, and that's okay, right? So because we're kind of cleaning up our act, we want to make sure we maintain the same level of organization going forward, right? So another folder we're going to need, and this is kind of an important distinction, guys. We're going to need two folders. We're going to need a modeling folder, and then we're going to need our predictions folder. Here's why I say that. Remember that our deliverable to our client, and in most situations that you're going to work in, is not training code. It's prediction code, right? The client doesn't care how to train the model. They care how to execute the model for future usage. So this is something that they really don't teach in academics, because in academics, you might only use the prediction code for a couple of different items, some previously, unlabeled data set or something like that, right? And then you turn it into your professor and then you're kind of done, right? But when you're working out there in the real world, your prediction code is your product. It's not your training code that's your product. It's your prediction code that's the product. Or when I tell you guys about how, in the real world, your algorithms are usually consumed by some other bigger project, right? They take your code and they implement it into Salesforce or into a mobile app or into something else, right? Well, in that scenario, you're not handing over the training code, you're handing over the prediction code. And they want it to be, lightweight and fast and, to kind of almost act like its own library, right? That's going to be some of the requirements that they give to you. Give me your fastest, most lightweight prediction cycle code, right? Or sometimes they'll refer to it as your runtime code, right? So right from the very beginning right now, I want us to draw that distinction. We probably won't do prediction code today, but we will in the near future. We're going to be doing a lot of modeling code today. But keep in mind that you kind of want to make those separate, because your prediction folder and that code almost becomes like something that you kind of put together in a delivery package, right? The modeling code is kind of like where you'll be doing the most of your work now and in the future. When they ask you to, to look at your code, look at your model again and to do some maintenance work on it, you're going to be doing maintenance on the modeling side, not the prediction side. You might create a new predictive model, right? Or a new predictive piece of code. But for us as data scientists, we're going to be working in the modeling side, but our deliverable, our final product is the prediction code. Okay? My gut tells me I might have lost a couple of you there, because it's a new concept if you've never been out there in the real world. But I guarantee you this is how it's done out there, okay? Our final product is the prediction side, not the modeling side. The work is the modeling side. But, you know, as we progress in this series, you guys will see that. Give me some feedback. Let me know if you're still okay with that. If you have questions, that's cool too. But it's going to be, it's a little bit different. Okay, thank you, Rex. Rex says I'm following. Okay, cool. Thank you, Rex. All right. So in the modeling section, let's go ahead. We know we need a new file, right? Let's go ahead and do that. In modeling, we need, what are we calling this? We're calling this time series, right? So time series. Modeling.py. And just to prepare for the future, and just to kind of give you an idea of my naming conventions, excuse me, we're also going to create a similar one in the predictions folder called time series prediction. Okay, so time series modeling is where we're going to spend most of our time today. This is where we're going to do a lot of the heavy lifting today. And we're basically going to focus on the same items that I mentioned to you before. What are the hyperparameters? Are there any other items that we can add to our hyperparameters? And what are the reports, or what are the metrics that we can create to help us along, right? So let me bring up a file here. I apologize that I didn't have this prepared earlier. Give me just a second. It looks like I don't have that. What I wanted to do was I wanted to bring up some of the items that we've looked at before. I'm going to try to find it on my machine, so give me just a second. Might be this one. No. Yeah, okay, here we go. So just to remind everybody, and also again, I know we have new people. This was one of the outputs that we were getting from our previous time series efforts, right? This is an output that's basically using the model from Prophet, from the library Prophet. So if you remember, the light blue band is the entire range that Prophet predicts. The darker blue, this blue line kind of down the center of the band, is the inferred value, the y hat value, right? And then, in other words, that's what Prophet thinks will happen, right? And then the most volatile line, the medium blue line, right, is the ground truth, what actually happened. So ideally, two things. One, you want the ground truth to stay within the band, right? Because that speaks to the accuracy of the upper and lower bounds that profit is giving you. And then you also want these two blue lines to be as close to each other as possible, right? Because that means that what profit thought was going to happen closely matched the ground truth of what actually happened. So the closer those two lines are together, the less they diverge from each other is another way of saying that, then the better your model works, right? Because now you know that your model is very closely aligned to what your what you were to what actually happened, right? Your model closely predicted what actually happened that day, the next day, or whatever it was, right? So I'm presenting this because I'm coming back to the first part of our champion model process, and that is, what is the metric that we're going after? Right? Like, what is the metric that we are optimizing for? So question in the chat, right? This is time for participation. Can any of you think of any metrics we can use to measure how closely the inferred value match the ground truth? Are there metrics available for that? Feels like there is, right? What do you guys think? If you attended my previous sessions on the ISL book, you should know this, right? But what do you guys think? Is there a measure we could use? So think about that, and I'm going to answer Matt's question here. Matt says, do the spikes that fall outside of the uncertainty interval represent outliers that we might not be able to want in our model to be able to predict? So Matt, great question. And it's actually the reverse of that. It's basically times when the model failed. The model's upper and lower bounds were not accurate in telling us what the stock would do that day. So it's not that we don't want those data points, because what happened, right? And we should want that in our data set. But it does mean that these are like the biggest failures of the model, right? Because in some cases, you're going to have clients that tell you, okay, great. I don't care how accurate you are in the value, just don't lose me any money, as an example, right? Or don't go outside of these boundaries. That's kind of why we have those ranges, right? Because also, people understand, right? Numbers have variance, right? Nothing in life is a straight line, right? So we can't prevent the spikes, Matt, but we do have to observe them as saying, whoa, wait a minute, that's a terrible failure of our model. Because in theory, that really shouldn't happen on the upper and lower bounds, right? It speaks to the weakness or the strength of a model. But good question. Okay, so Yassine and Denelson are both offering up MSE. So for those of you that are newer, that stands for mean squared error. So Yassine and Denelson are correct. MSE is a great measure for judging how close your inferences matched your ground truth. Because MSE is basically a measure of, this is what I thought I was, this is what actually happened, and what's that difference? What is the value of the difference? How much did I miss by? Right? If I know that life has variance and it's not gonna be a straight line, it's not gonna match every single thing, then by what degree did I miss? That's basically what MSE tells you. It's a square of the mean of all the errors. Because any time that you didn't actually match the inference, where your inference didn't match reality, ground truth, that's a mistake, right? But how much of a mistake was it? So, what are we optimizing for there? Do we want a high MSE or do we want a low MSE? What do you guys think? All right, Denelson, Yassine, and Leo, they all say low. That's exactly right. That's exactly right. Osama also low. Yep. That's exactly right. You want an MSC as close as possible to 0 as you can. You're very unlikely to achieve 0 because that means that every single time you predicted something, it came true, right? Not likely to happen. But you want to get as close to 0 as possible. So a low MSC is ideal. Manoj also says low. Yeah, thanks guys. But yeah, if we know, so coming back to Matt's question, right, about these spikes, right? And we know that an MSC is basically like a measure of this spike, right? Because it would in this instance here, it would take the difference between this prediction and then this ground truth and kind of add it to the mean value, right? So yeah, you want it to be low. You want these lines to be as converged as possible, or you want the model that gives you lines that are as converged as possible. That's exactly right. So that's it, right? We have the first elements that we need for our champion model process. What are we using? We're using MSC, and what is like the golden metric, or the best possible scenario is the lowest MSC possible. So that's the goal right now, right? That's your guiding light. What is the time series model that gives you the lowest MSC possible? And then what are the hyperparameters that you're putting into that model? You find the combination that fits all of those, and you're done. That's your gold, right? You strike gold when you get the lowest model, the model with the lowest possible MSE. Like that. That's the work that we're pursuing today. Okay. So we have a blank file. I'm going to keep this open just in case we need it. We have a blank file. We are not going to write any of the code ourselves. As a matter of fact, we know that we have, actually we can close it. We're not going to use that. We have other code, right? We have our profit code. So we can start with this code and we can say, hey, this is where we're at now. But can you help us write this with hyperparameters, with other things? And that's what we want to do. Okay? All right. So what I want to do is I want to use this as like I said, as the initial seed to ChatGPT. We're going to add it to ChatGPT's context, right? And then we're going to ask ChatGPT to use this as a base to be able to say, where do we go from here? So we need to make a couple changes to reflect our new folder structure, right? So we know that we moved this file, we moved it to data, and then we know that it's going to be the same Microsoft file. That's okay. We'll just keep focused on Microsoft for now. And then here we know that we only need 2 columns. We need a date timestamp, and then we need to know the price on that day. And we're getting that from the CSV file. The CSV file only has 2 columns, right? And let's go ahead and verify that so that everybody can see that. This is the file we're using, right? 2 columns, date and the price. And we're using 1 year's worth of data. Data itself is not a hyperparameter, but there are instances where we can use more data to help improve the models. That is possible. So I don't want to do that just now because, again, I don't want you guys to think about it as a hyperparameter. But that's something that you want to consider, because I know the question is going to come up. Well, why are we only using 1 year? Well, we can modify that. That's totally okay. But I don't want to start with that right now. I want to I want to keep us open to other possibilities. Okay. But right now we're going to be working with a year's worth of data, 2 columns, timestamp and the price. That's it. That's all we're going to need. So we know what's in that folder. ChatGPT is going to go ahead and say, drop all your null values. I don't think we should have many because, you know, this data is pretty clean. Here is where we're fitting the model. And then here is where we're doing the forecasting, right? Everything else after this is the plotting. Okay? Do you guys think we need plots here? Because I'm going to propose to you guys that we don't need plots. These plots were fun for us to explore with and kind of make it a visual exercise. And you want to do this, you know, in the real world. But remember that when we're running these combinations of hyperparameters, we're going to be running literally hundreds and thousands of experiments. So us checking these plots by eye for every single model is not efficient, right? So what I want to do is I want to go ahead and say, I don't want the plots, but I do want the MSC results, right? So we're gonna basically leave out this bottom portion of code when we show this to ChatGPT. We want to go ahead and say, don't do a plot, but keep a CSV report of everything that happened, right? That's very healthy for us to do. So Leo asks, more data or new features? Yeah, Leo, you can do both. You can do both. I didn't mention new features because that is kind of one of the funny things about Prophet, that it only requires 2 inputs. That's it. Like if you look at the documentation put out there by Meta, that's all they want. That's kind of like why Prophet is unique, why it's, you know, kind of caught people's eye, because they claim that they can do it just based on those 2 inputs, which is, you know, quite a claim, right? You know, yes, they take some seasonality into account, and because they're doing some things on the time series side and things like that. So I know I'm not making 100% accurate statement, but yes, Leo, in other situations you would want to seek out other features, more feature engineering, enrichment. But in this particular scenario, we're going to go ahead and stick with the 2 columns because that's all we really can input. Okay. All right. So let's do this. We're going to go to our employee, ChatGPT. So we're going to set up some of the context, right? We're going to say, hey, here, I want to give you some code and then I want to make some changes. So let's start with that. And I'm going to pop it in here. And this is us just setting up the context, right? It gave us things for improvements, which is good, but that's not quite what I want to do just yet. I want to guide I want to guide our changes along a little bit. So first thing I want to impress upon all of you is, remember how I said we're just doing explorations, you know, and that's okay. One of the things that I stressed in our previous series that I want to come back to right now is that there is a difference in Python between scripts and programs, right? The overwhelming majority of stuff that you find online are going to be scripts. Those little things that you find, or sometimes ChatGPT writes for you, those are scripts, and that's okay. But in professional data science and really kind of professional Python development overall, you want to focus more on programs. And by programs, I mean you want to focus more on writing classes. You want to have a main entry point. You want to do a couple of different things that, one, add a little bit more polish and professionalism to your code, and also make your code extensible. Because now, if you have that file that is now a program, well, that program, that class, can be consumed outside of another Python file, which is very likely to happen, right? So that's the first thing I want ChatGPT to help us with. We need to formalize our code into more of a class and main entry point function, because that way it's a little bit more, it's just a lot more extensible that way, okay? So let's start there. Let's see what ChatGPT gives us. So same imports at the top. It's going to give us a new class called Stock Price Forecaster. That's a nice name. It's going to set up profit, right? Because you don't need to instantiate profit until you're working in that class. And then it's going to load the data. It's going to tell you where the file path for the data. It added its own try catch, or try except, which is great because we didn't have that before, and professional code should have try excepts or try catches. You can see here it's using the same two columns, dropping the NA values, and it's going to go ahead and do a fit model and a make forecast function. And then it also does a plot forecast function, which again, we don't need right now. But that's okay. Here's our main function. It's asking us for a file path. Here's the instantiation to the forecaster, which makes sense. And then it's going to do another try except, where it loads the data, it fits the model, it makes a forecast for the next 7 days, and then it plots the forecast. And then down here you have your standard Python main entry point. So let me copy this over and let me bring this over to VS Code. So now we're ready to leave this file in VS Code and go to our new file, right? Our time series modeling file. Because the previous file we looked at, the one that we set the context in ChatGPT, that was our exploration. But now we're ready to be a little bit more formal and put it into our actual modeling file, right? Because this now kind of becomes like the base that we're going to be working from. Okay. So I'm not going to ask this as a question because I think my purpose here is not to embarrass anyone, right? But I'm guessing that for some of you to see this declaration of the main entry point, and then we have a main function, and then we have a class up here, I'm going to guess that for at least some of you, this is new to you, right? Because, for example, if all you've done is work in notebooks, you don't need that, right? Notebooks don't require that type of structure. But that also becomes their weakness, right? Because that's the reasons why you really can't deploy a notebook, because they don't have those defined entry points. Notebooks are mostly very sequential in how they load and run their code and all that. And they're also very visual, which you really don't need in most enterprise deployments, right? But these are the types of things that kind of differentiate, whether you're just still kind of like a student or like an amateur studying on your own versus being a professional data scientist, right? Knowing how to break out your code, knowing how to, the classes you're going to need, the way you're going to structure those classes, all of that, right? So if this is new to you, that's okay. You're probably not alone. I think people are just too embarrassed to say it, but you know, it's quite different if all you've ever done is Python and notebooks, or, you know, the tutorials that are online. Okay. All right. So to me, this looks like all like very reasonable code for our first run, in the sense that we have a good class. We have our reference to our data file, you know, the same Microsoft data file that we have. And this will give us, you know, pretty reasonable stuff, right? So one thing that sticks out to me is that we don't need a plotting function. We at least don't need the call to the plot forecast, right? We might just go ahead and keep the plot forecasting so we can use it in the future. We'll keep that in the library. You know, maybe it's not something that we'll use a lot, but what we really need is we need a report. Well, we need two things. We need to one, build a way to try different hyperparameters, and two, we need to have a report that tells us, hey, this is how your hyperparameter run worked out, right? So what are the hyperparameters? What are the levers to pull, right? As I told you guys, right? That's what I'm always looking for. Give me levers to pull. What are the different things I can try? Right? That's kind of what you want. That's where you really start giving yourself an opportunity to find that good model, right? Okay, so again, we don't have to know everything. We have a new employee, right? ChatGPT is our employee, right? So we need to know two things. We need to know, one, what hyperparameters are available, and two, what is a reasonable range for them. Because remember, these hyperparameters is how we determine what we want to search for, or the values we want to try. But you have to have some understanding of what that range looks like, right? So I'm going to ask that of ChatGPT, and it should be able to guide us. And also, please show a reasonable range. Values along with an explanation of what they do. All right. There we go. Okay. So it's going to tell us the list of key hyperparameters, the reasonable ranges, and explanations for what they do. So there is a growth hyperparameter. Specifies a type of growth model to use, whether it's linear, logistic, or, well, I guess it's just linear or logistic, right? That makes sense. Default is linear. Use linear for time series with steady growth. Use logistic for data sets where growth levels off or saturates. Okay, good to know. Change point prior scale, range of 0.001 to 0.5. Seasonality, whether it's additive or multiplicative. Multiplicative, yeah. So that's another one to try. Controls the flexibility of seasonality components with the seasonality prior scale. 0.1 to 10, default is 10, okay. Basically, how sensitive are you to seasonality? Would stock prices be susceptible to seasonality? Let me know. I have some ideas on that, but I want to hear your ideas. What do you guys think? Do stock prices have seasonality? You saw the Microsoft chart, right? Is seasonality there? What do you guys think? Leo says, great way to start a question. Thank you. Shilpati says, hi Dennis, I have always worked on notebooks as a student, but now I'm using Power BI at work and I still use a notebook. No, I would encourage anyone who is still using notebooks to start relying on them less and less. Of course, you're also going to do like personal explorations. I feel comfortable working in code, so I do all my stuff straight out in code, even like basic explorations. If you want to keep notebooks for that, okay. But if you want to do professional data science, you kind of want to get away from that, okay? So I would encourage you to, it doesn't have to be a night and day difference, right? But slowly start to get away from that. I think you're going to find benefits in that, Shilpati, okay? Okay, so we have two competing opinions, guys. Yassine says, I think they can have seasonality. Leo says, I wouldn't say there's seasonality on stocks. Ruben, our new friend Ruben, says, yes, I think retail brand equities might be more susceptible to seasonal earnings. Yeah, okay. Now, Ruben, you're hitting on an important part there. All of these companies have to report their earnings, and they do it quarterly, usually, right? And they have their calls with their investors and all that, right? Now, I know you mentioned the retail sector specifically here, but wouldn't the fact that all companies, regardless of sector, have quarterly earnings, that in itself have a seasonal effect on our data? Right? Because remember, we don't care what the company does, we just care what the data does. So I'm tempted to say that there is seasonality just because of that quarterly reporting or that year-end reporting, right? So we almost kind of have to think about it at a higher level about the fluctuations in the data, right? So we're not really asking, what does the company do? Is the company a retail company? We're asking, are there times of the year where that data would fluctuate more than others? Because that's seasonality, or a form of seasonality, right? Like, doesn't that happen? So Prajwal, welcome. I think it's your first time. Glad to have you here. Seasonality should be a factor, but I think recognizing exogenous factors would be a more important factor. Maybe, but that's part of this library, right? That's part of Profit. Profit says, you know what? We don't care. We just need to know your dates and your prices. Right? That's kind of like the unique part of Profit. Shilpati says, thanks, Dennis. You're welcome. I hope it helps, Shilpati. Shilpati, I see that you are on Instagram. You're welcome to stay there. But if you want a wider view, you can also join us over on YouTube, okay? Matt says, quarterly reports might have an impact, but that reporting might be good or bad. So wouldn't quarterly reports mark points of fluctuation without predicting direction of those fluctuations? Yeah, but Matt, that's okay. We don't care about the direction. We just care that it went up. It went up or down more than usual, right? So you're on the right track, but direction does not matter. Like in our seasonality, we just care that there was some reason why this time period would be more active than this other time period, right? Because remember, the only thing we're giving is a date and a price. That's all we're providing. So it doesn't matter if it's a retail company versus a construction company, that it went up, it went down. It just mattered that on day X, there were more reasons for it to go up and down than day Y. So in that scenario, I think there is a seasonality. But having said all of that, remember that I'm kind of just asking for fun here. We're part of the champion model process, this hyperparameter, is that we're going to try a lot of these hyperparameters. So I'm kind of asking for fun, keep some conversation going, but we're going to try them all anyways, right? So as we go on, we will see how some of these theories of ours hold true. Maybe the champion model will have low seasonality, or maybe it'll have high seasonality. Or maybe it'll be somewhere in the middle, right? So we're kind of just throwing around our own personal hypotheses and really kind of our personal biases, but we're going to try them all anyways, right? It wouldn't be much of a search if we biased ourselves, right? Like don't bias. Let's not bias ourselves, right? That's not very scientific, right? But good conversation, guys. Okay, so seasonality is in there. Holidays prior controls the influence of holidays effects. Okay, because again, profit is doing that underneath the hood, right? Profit is considering the holidays and all that. A change point range, proportion of historical data within which change points are placed. Okay, 0.8 to 1.0. Okay, yearly seasonality, weekly seasonality, daily seasonality, whether it's true or false, to disable the seasonality component. Set the number of Fourier terms to control seasonality complexity. Okay, automatic detection based on data. Oh, that's interesting. The N change points is the number of potential change points for trend adjustments. Lower value result in fewer trend changes. Higher values allow for more frequent trend changes. Okay. MC samples. Number of Monte Carlo Markov chain samples for estimating uncertainty. Range is 0 to 1000. Okay. Higher. I cannot read or talk today. Use higher values for data sets where uncertainty quantification is critical. Ooh. That's an interesting comment. Interesting hyperparameter, right? Where uncertainty quantification is critical. Does that sound critical for investments? Uncertainty quantification? It does, right? You kind of want that. So, very interesting samples here. Excuse me, hyperparameters here. Width of uncertainty intervals for forecasts. Lower values produce narrower uncertainty intervals. Higher values produce wider intervals, showing greater uncertainty. That sounds important, right? That sounds really important. Okay. So it gave us 10 different hyperparameters. So let me look at the chat again. Matt says, okay, I'm used to seasonality in marketing, which normally gives us a direction as well. Yeah, I hear you, Matt. And it's important in other functions, but in data science, we kind of don't care. We just care that it happens, not necessarily the why or the direction. Well, excuse me. We don't care about the direction, but we're trying to find out the why or the net effect it has on our model, right? So Prajwal says, I believe Profit tries to figure out seasonal impacts using timestamps by extracting day of the week and so on. It may work well for stock prices, but not in a lot of other data sources. Yeah, but that's okay, right? Our client wants the stock info from us, right? That's the task that's in front of us. But yes, you're right. Profit is doing a lot of work underneath the hood to look at your date times and whether it was weekends or whatnot, and make its own adjustments, right? Yes, but Dennis, the reports have any effect on the assets? Wouldn't it be better adding other indexes? Leo, it would, but again, Profit doesn't allow for that. Profit literally just takes in 2 inputs. If we were doing our own like homegrown time series, like a REMA standard or something like that, then yeah, we would do that. But in this scenario, like there's no other choice. Like it's literally just 2 inputs, right? So Yassine and AJ are saying yes, absolutely. I think you're talking about, the importance of that hyperparameter on stocks. Yeah, super important, right? Because it comes back to that volatility, right? I want my y hat upper and my y hat lower, which are my inferred values for my width or my range of the day. I want that to be as narrow as possible because that would be lower volatility, right? So just to illustrate that for people that might be lost, it's basically an effect that's going to have on the width of the blue band, right? Of the uncertainty interval. So yeah, of course we want that as narrow as possible. So a couple of those hyperparameters, yeah, super important, right? So interesting stuff there. Leo says the live might shut down if we apply that, but it's cool. I can't remember which hyperparameter you said that around Leo. Prajwal says, sorry if this comment derails. I just want to introduce myself. I'm a senior data scientist at Indian Space Research Organization. I have worked on modeling time series data for spacecrafts. Cool. Very cool. Prajwal, thanks so much for joining. Really appreciate you. Okay, Leo is saying the Monte Carlo one. Yeah, okay, I see your point, Leo. Yeah, you know what? Leo is actually hitting on a very important point here. I think that we got 10 different hyperparameters, right? And it also gave us a range of values for each one of those. So some of you can see that we are going to have a variety of permutations coming up very, very quickly on what our searches are going to be like, right? And some of these hyperparameters are a little bit like heavier or more intense than others. So to Leo's point, the one that was looking at the what was it, the Monte Carlo Markov chain simulations, yeah, that's going to be a super heavy hyperparameter to tune, right? We might want to start a little bit on the lower end of that until we get into more dedicated hardware. Because remember, right now we're still doing everything locally. I'm gonna have a whole Sunday session that's just on the deployment side, right? Because this is nowhere near client deployment. This is us just kind of building out the code. So yeah, I hear you on that, Leo. Some of these are definitely going to be very intensive. I know that I've run some things on, using Prophet that even on my cloud hardware, right? Because I maintain some cloud servers. Even on the cloud hardware, it took like multiple days to run. So yeah, we're gonna definitely run into that, Leo, right? Because after today, the complexity of the code definitely takes a step up, and then from there, the hardware requirements will follow, right? You're gonna need more hardware or more complex hardware. But we'll see what limits we can hit today. And I'm gonna show you a couple of tips and tricks that I use, okay? So, good discussion that we've been having. But here's the thing, guys, right? Again, some of these things I'm kind of just asking for fun. But the reality is that we don't want to bias ourselves, right? We should be trying as many of these as possible. We're going to try all hyperparameters, and we should be trying as many values as possible. Because again, we don't know where the answer is. And this comes back to our discussion from yesterday. We can develop our own ideas and, oh, that sounds good, that sounds promising. But the reality is that you don't know where the answer is going to come from. How do you defeat that? Well, you try every combination possible, right? There's definitely a little bit of a brute force application here of this champion model search, these permutations that we're going to try. And by the way, I should have mentioned this earlier, I'm sorry. But sometimes in some documentation or tutorials or whatever, you're also going to hear this referred to as a grid search. Grid search, champion model search, permutations, those are all kind of synonyms in this situation. Because basically you're creating an entire grid of all the possible permutations of these hyperparameters, and you're kind of just working your way through it, right? You're searching your way through it. So that's basically where we're headed with this. And we know we can do it with these 10 hyperparameters. Right? Okay. We have our base code that ChatGPT helped us produce, right? Which is here in our Visual Studio Code. Let me bring that up, right? Pretty good code, right? But now we're going to write our most complex, our most complex prompt. Because in this next prompt, we need to tell ChatGPT to create a structure where we can use the different hyperparameters. And then we also need to save the model that beats our current baseline. And by baseline, we've already agreed that it's going to be the MSE. So we need to write all of that into a prompt for ChatGPT. It's going to be pretty complex, but let's see if we can get this right. By the way, it's going to be complex for us to write, and it's going to be complex for ChatGPT to put together, right? So personally, I'm going to be really impressed if it gets it right the first time. Because again, guys, if you're still starting out or, you're still new to data science or whatnot, this stuff is definitely where like the level of complexity of you being a data scientist definitely goes up. Okay. All right. All right. So as I was writing about it, I was thinking about maybe kind of breaking it up into two parts. But this is still our most complex prompt to date. So we're going to ask it to take the previous code file, and we're going to add code to support the testing of 10 of these hyperparameters. And we're going to ask it to generate 5 values to test for each hyperparameter. Now, some of these were true false, so I had to add a combination of when possible, right? And then after each run, and actually that's a poor prompt. After each model fit is what we really want to specify, right? Because each model fit is going to use a different version of those hyperparameters, right? Every time we call model fit, that's basically the execution of the experiment. So after each model fit, please write to a CSV file with the results of the test. I want the CSV to contain the value for each hyperparameter and the MSE that was associated with that run. And also, that's another. I want to clarify. It should be a single CSV should contain the values for all of the hyperparameter tests. Okay. Because I didn't want it to create a CSV for each single test. I want all the tests to be contained in a single report. that we can refer back to. Okay? So let's see what happens here. Okay, so it tests all hyperparameters of the range of values, calculates the mean squared error for each run, and writes the results to a single CSV file. Okay, that's a pretty good interpretation of what we wanted, right? So let's go ahead and copy this code, and let's take it to our Visual Studio. That way it's a little bit easier to see. And we're gonna go ahead and trust that ChatGPT got it right. That's our class. Oh wait, I didn't finish. I must have only did a portion. Yep. Let me copy it again. It wasn't done writing the code. Let me copy that. There we go. Okay. So now we're up to 130 lines, which, by the way, guys, if you're keeping score at home, this is the longest code file we've ever had ChatGPT write for us. Right? Most of the things we've done have been pretty short, right? Relatively short. 130 lines. That's the most we've ever had to do. All right. So let's start with our main entry point using the data. And here's our results file, hyperparameter results.csv. I don't know why it put it one level up, but that's fine. We'll keep that for now. Run the hyperparameter testing process, load and prepare data, test hyperparameters, and it's gonna send it to the results file, or send the path of the results file. So let's go up here. It looks like we need to add scikit-learn. That's weird, because I'm pretty sure we already have scikit-learn. I don't know why this one is causing problems, but we'll see. So that's the initialization. Okay. I'm making an observation here, and I'm pretty sure I know what's happening, but we'll find out soon. It's going to load and prepare our data, right? The same 2-column file that we have. We have the 2 columns, the dropping the NAs, and then stock data is, here it's setting the variable, the class level variable for stock data, which makes sense. Here's our hyperparameters, or the hyperparameter function, I should say. And then these are the hyperparameters, right? And you can tell, and you'll notice that it's calling it a grid, which is common. Like I said, it's a grid search, right? So this is going to become our parameter grid, and these are all the different values that it's going to test for us. So seasonality, weekly, it has, the binary values, and then it picked 5 values for each one of the other ones. So that all looks pretty reasonable. We're going to have to double check this with the ranges that it gave us previously, right? Because we want to make sure that the code was accurate. And 2, very important here, guys, you want to test things outside of the recommended ranges. We want to make sure that it didn't just give us the recommended ranges. You always want to test the top and bottom as much as possible, but then you also want to try other things, right? The non-standard values, because again, you never know where the answer is coming from, right? If you only look at the reasonable values, then you'll never make any new discoveries, right? So keep that in mind. We're gonna have to change that. And then it's 1, 2, 3, 6, 8, 9, 10. Yep, it's got the 10 values. So it's gonna go ahead and turn our grid into the combinations that can actually be pumped into the testing code for profit. And then here is the heavy lifting. You see this loop? This loop basically contains all the permutations of everything we're asking it to do, right? So you guys are smart. I'm sure some of you have already quickly figured out how many permutations this is, right? This is 2 times 5 times 2 times 5 times 5 times 5 times 2, right? Lots of permutations here. This loop is where it's all happening, right? This loop is instantiating the model. It's going to fit the model, right? This is where the magic happens. It's going to make our predictions. And then here, it's going to tell you, well, it's nice that it put a print statement so that it'll show us the MSE as it goes along, right? And you do that to kind of track and feel where your results are headed, but you're also doing that to kind of get some feedback to know that your model is still running. Because some of these loops are going to run for like hours and hours or days, right? So you kind of want to do some output just to, signs of life thing, right? And then here, it's going to go ahead and append the results. I believe that this is a list, right? The results append, which is okay. And then once the entire loop finishes, it goes ahead and puts out the results to the CSV, right? So now we're going to have this results file that we can look at and quickly scan the MSE and say, oh, okay, yeah, that model looks like it's the one we want to do. And that's it. That is essentially a fairly solid champion model process. I don't know if this code is going to run error-free. To me, it looks pretty reasonable. But this is exactly what a champion model process should look like, right? This is how it all comes together. You are supposed to try as many of these permutations of as many hyperparameters as possible. And I think from what just by eye, ChatGPT has done a reasonable job of helping put all of that together. The code here looks pretty reasonable to me. There's just one thing I don't like, and what I don't like is that it only outputs the results to the CSV at the very end. It would be helpful if it did it as it was going along, because sometimes I'll also monitor the growth of that file, because that also tells me that the process is running as desired, right? But it's not the worst thing in the world to write it at the very end. It also means you're going to be taking up memory, right? Because these results, that list of results, is going to just take up your memory as you go along. So that's kind of counterproductive, right? Because you're taking up your memory as you're trying to use memory to run your models. So it's kind of, it's like that hustling in reverse, right? So I'm not keen on that part of it, but maybe ChatGPT can correct that for us, right? AJ says, I hope it uses scikit-learn. We'll have to see why it had an error on that dependency. I don't know why Visual Code is showing me that. Denelson says, in your opinion, is it better to use a standard grid search or to use a randomized grid search? Yeah, Denelson, great question. But a grid search will basically do that, right? Okay, I'm sorry, but maybe I'm misunderstanding your question. Are you referring to how we select the values? I think you're referring more to how you select the values versus how we're running the code, right? Because the run is going to try every single permutation, right? There are some exceptions to the statement I'm about to make, but no permutation will be left out, right? We're going to try everything. Here's the exception to that. In neural networks and in some other models, there is a concept known as early stopping, where you would stop the training if you don't see your model improving. And you can tie that to some of your hyperparameters, some of your grid search values. So that doesn't apply here, because this isn't a pure neural network play. But we're going to try all the values anyways, right? So Denelson, I'm going to go ahead and assume that you were referring to how we actually create these values. So guys, just in case you kind of need to catch up there, Denelson is referring to how we create the values in the grid search. Obviously down here, you can see that there's a structure to 5, 10, 20, 30, 50 change points, right? And these are all reasonable values. So Denelson is asking, should these values be randomized? So here's the thing, Denelson. Here's where things get interesting. And again, this is the work of a data scientist, right? A grid search is not a one-time thing. A grid search can be an iterative thing. Nobody tells you that. None of the academic books tell you that. Your professor is not going to tell you that. But people tend to think of grid searches as a single use item, and they're not. They're a very powerful tool, but a lot of people don't realize that you can just use them over and over again. So to answer your question, I like the values that are produced here. Like I said, I want to double check to make sure we're trying some of those like weirder values. But here's the thing, Denelson. We're going to learn a lot from this experiment. And we're going to see where the MSC is headed. And if you can say, okay, cool, here's my lowest MSC for this run, we're going to go look at the parameters, right? And then we're going to look at those parameters and say, okay, well, what happens if I try a little bit lower or a little bit higher than the parameter that I know works? And then we're going to run it again. And then we're going to see, did that improve? Okay, yeah, it improved. So let's do the same thing again. And we're going to do over and over and over again. That's a form of experimentation. That's a form of grid searching. Right? You can do that. We can kind of start to converge on those answers. And the end result will look like some of those randomized values. So this is what I mean when I was telling you guys that you're kind of in this loop. Let me go back here. You see this arrow? This arrow here implies that loop of the model design, interpret results, model design, interpret results. So that's what I'm describing there, right? That we can continue this in perpetuity, right? It's really just until we run out of time with the client or a deadline, right? But Denelson, we will eventually get to some values like that where like it won't be just like a value of 10 because it was a multiple of 5. We're going to get to a value of 13 because we were converging on those values after trying this over and over again. Okay? So that's definitely something that it's going to happen just by the natural course of what we're going to do. Good question though. You know, and building upon Denelson's question, because this is something else I want to get across to you guys. Very, very important. So, yeah, I mean, I'm picking my words carefully here because this is a super important topic. If you're going to write something down, write this down, guys. If you're looking at this and you're looking at all these values and all these grid searches, and you know, maybe you've done the calculations in your head of how many permutations this is and all this other stuff, right? Some of you might be thinking to yourself, like, wait a minute, you're telling me that I'm just gonna like try all these numbers? Like isn't that kind of like isn't that just kind of like brute forcing yourself to an answer? Like you're basically feeding everything you can to these math formulas. And you're telling me that if you do that enough times, you're going to get to something that's like can predict the stock market? Like you're telling me that you're going to brute force your way into a math formula by trying everything, and somehow that magically becomes this algorithm that like does wonders? Are you insane? So I'm telling you that to you guys because that is the exact argument that people against data science will tell you. That's one of the arguments that they use. If you, I'm pretty sure that if you go and read the book on causality by Judea Pearl that I've recommended in the past, I'm pretty sure that book starts off by talking about the same thing. But what you're seeing here, like these grid searches, the champion model search, we're going to try all these permutations, there's all these hyperparameters. This is the counter argument to data science. Like, write this down, right? Because somebody will tell you this in the future. But this is why some people out there, and I'm talking like I'm not talking like crazy. I'm not talking like crazy people or conspiracy theorists. I'm talking like academics or causality experts, right? Like, this is the argument that they use against data science. That essentially, well, there's no magic to it. You're just trying everything under the sun. And then this is also why they say, well, what if your data changes? If your data changes, then you got to rerun all of these 10,000 experiments you're about to do. Right? Or, you're not doing anything special. You're just trying everything. Like, that's the counter argument against data science. And I'm telling you this because there are people out there who will give you counter arguments to why your algorithm is dumb. Right? So you got to remember that, guys. All right? Like I said, write this down. Because what you're seeing here, this is, like I tell you guys, this is the work of a data scientist. Like, this is where we're doing the heavy lifting. This code is going to take a long time to run. But this is exactly what people will also point to and say, well, data science is not magic. It's just trying everything, and it's a math formula. So keep that in mind. Super important. Matt says, if you torture data long enough, it'll confess to anything. I like the way you put that, Matt. Yeah. And again, you'll hear that in the future. Somebody will tell you that about data science, right? So keep that in mind, right? Super important for you to remember that. And if you think about it long enough, it might even make you doubt your own your own purpose in life, right? Hey, maybe those causality people have something going on, right? Like, maybe they're right. All right. So where do I want to go next? So what I want to do is I want to try this code. I'm optimistic that this code will work. We have to figure out the scikit-learn, why that's happening. But what I really want to do is I want to get us to be able to view that CSV file that has our results, that report that we talked about, right? And also just make sure that ChatGPT gave us working code, right? So the problem is that there's way too many things to run here, right? This is a lot of parameters. This is going to take forever to run. So let's go ahead and start trimming some of these down. So again, coming back to Dennelson's question, if we were to kind of pare these down, what I like to do is I like to keep the min and the max. Let me try the low end, let me try the high end, and then let me try all those combinations. So let's start by doing that. We're going to take, of all the ones where it gave us a range or, integer values or numerical values, let's take out all the middle. Let's just do the high end and the low end. And actually here, that's not the high end. We can use that. Or I should say the low end. Let's do that. We'll keep all the binary true false. And then what does that leave us with? That leaves us 2 times 2 times 2 times 2. 2 to the 10th. What is that? That's still a reasonable number, right? Yeah, I think my local machine should be able to handle that. We're about to find out. But otherwise, I think it's totally reasonable code. So let's go ahead and go to our terminal. Let's actually execute something. Let's find out where we're at. CD modeling, right? Because we know we're in the modeling directory. Time series modeling.py. Leo, I love the enthusiasm, Leo. Leo says, "Let's go. God bless America." All right, so it seems like Leo's excited about this code. So Python time series modeling.py. All right. scikit-learn, no module name, sklearn. That's interesting. Let's go ask our employee ChatGPT. I think it was sklearn.metrics. Oh, wow. This is telling me I don't have scikit-learn? That doesn't sound right. I thought I had already done that. Oh, wow. I didn't have that installed previously? That's weird, guys. I could have sworn we did that. Okay. So let's run it again. No such file, data, MSFT. Somebody double check my Linux here because I always stink at this. So we are if we look at our data structure, we are on the same folder. We are in the same folder as data. So I thought that a dot and a slash would get us to that file, but it might be a dot and a slash. Somebody remind me to get one level up. I thought it was 2 dots, but I guess I thought it was 1 dot, but I guess it's 2 dots. Okay, data. Thank you, Denelson. And yeah, you know what? In here, I'm going to change this because I wanted to just put it in this same directory. All right, yeah, thanks for that, Denelson. I am terrible at navigating like that via code. Okay, cool. So I know you guys can't read it too clearly, but it's telling us what the MSEs are as we're going. Denelson is correct. Capital D, yep. Single dot slash means same directory. Okay, thank you so much, Sim. Appreciate that. Yeah, I'm terrible at that, guys. I'm terrible at that. So appreciate the assist there. All right, so I can see them because it's on my screen. I don't know how it's looking for you guys, but I can see the MSEs coming up. 297, 293, 34, 34. Uh, 34 again. I'm seeing a lot of 34s for the 297, 293, 316. So we're just gonna let this run. Leo says we're in the Matrix, baby. That's funny. I like the way you put that, Leo. That's hilarious. Denelson says beauty. Yeah. Guys, this is the work. This is the work of a data scientist. So again, typically, in most scenarios, this is a set it and forget it. We're gonna just let it fly overnight, over the weekend, whatever. You come back to your report, right? Because, you know, it's obviously fun to watch this, but you care about the report, right? What was the experiment I ran? What were the hyperparameter values? And what was the MSE? That's it. That's all you care about. We're going to let this run. Excuse me. The MSCs are coming up quickly enough where I can see that, you know, it's running at a reasonable pace, right? AJ says, hey, Dennis, what was the number of parameters it's searching just to calculate the possible time it would take? So AJ, we basically use 2 values for 10 parameters. So that's 2 to the 10th, right? Let's see if there is something saved. So Yassine, there is nothing saved right now, right? And that's what I didn't like about that code. I mentioned that. Right now, it's only saving it to the list. And there we go. So it's done. Now it wrote it to the CSV. So to your point, Yassine, we should change that so that it writes to the CSV as it goes along, right? That would be super helpful, right? But yeah, Yassine, there's nothing for us to check until it's done, unfortunately. Yes. Yeah, I know you're referring to the CSV, Yassine, but it's only available now. It wasn't available before. Sim says, ideally, something more understandable would print like 100 of 2024 complete. Yeah, we can do that. Yeah. But, for the purposes of us getting off the ground, this is still pretty reasonable code. But sure, we can pretty it up and all that. But at the same time, you're not going to sit there and monitor this, right? You just care about the report, right? Just tell me what was the best one and what were the parameters used so that I can recreate it in the future, right? Denelson says, will we be creating a visualization for it once it's done? Only on the good models, Denelson. Right? On the good models, yes, we'll go back and say, okay, let me see what this looks like visually. So Denelson, where we're headed with this, because remember guys, this is just the first iteration. So here's where we're headed. 1, I don't need you to save every CSV entry. I only need you to save the ones that beat the baseline. Right? That's the first thing. 2, I don't need you to save every fit model. I just need you to save the fit models that beat the baseline. That's the next iteration. And then the third iteration is only create a visualization for the new fit models that you're saving. So you'll have the same number of visualizations as you will the fit models. So we will do that, but we don't want to save every single one. That's a lot of disk space. We just need to know the better ones. That's the champion part of it, right? That it's like a king of the hill game, right? Here's where the baseline is. Can you top it? If not, I don't care about you. You don't exist to me, right? So we'll do that in the next iteration. So let's pump the brakes there, Danielson. We're gonna go one step at a time. All hail the MacBook Air. No, the Mini. I'm using my Mini today, Leo. All right, so Yassine wants to see the CSV, and so do I. So there it is. There's our hyperparameter results. And this is it. Okay. Wow, that is a very good looking CSV. So across the top, each one of these is the hyperparameter, right? The growth, the change point, seasonality mode, seasonality prior scale, holidays. So basically there's 10 of these, right? Because we know, well, there's 11 because of the MSC, right? So MSC is our last column, right? So now what we want to do is we want to check our MSCs. Denelson says, I'm sorry, just get excited when we get to the experiments. Well, yeah, you know what, Denelson, to your point, it's nice that we're doing that, right? Because I fully admit that maybe some of the previous sessions didn't really feel like a lot of data science work, but I guarantee you're going to be doing that. Today's session definitely feels like more dedicated data science work, like we're writing actual testing code. We're working with data. We're working with scikit-learn and Prophet and Pandas, like the stuff that you're used to, right? So yeah, I mean, it is an exciting day. You know, it is an exciting portion of the overall process, right? But you know how like you hear people tell you like, oh, data science is 80% data cleanup. Yeah, they're right. It's nice for us to enjoy days like today where this is like the heavy lifting, right? So appreciate your enthusiasm, Denelson. Okay, so let's start looking at some of these MSCs, right? So 34, 294, 293, 35, 34, 33, 34, 293, 34. Okay, so there's clearly a pattern emerging here, right? We're either super high or, I don't want to say low. We're either super high or we're in the 30s, right? Because there's a 34, 35, right? So we shouldn't be surprised by that because we know that we use the upper and lower bounds, right? We did that intentionally, right? Excuse me. So we shouldn't be surprised that we're getting, very polarized results, right? That's not a surprise. But we said that for MSC, we want lower numbers, right? So those are the ones that I'm looking for. I'm looking at all the lower numbers, and the lowest I see is like a 33 or a 34. Is anybody excited by that? Is anybody excited by an MSC of 33 or 34? Let me know in the chat. Give me some feedback on the I'm not going to say low. I'm going to say the bottom end of where we're at. Anybody excited by that? Give me some feedback. 316. Let me know if anybody's excited. 32. Okay, there's a 31. A couple of 31s there. Oh, wow. Is that a 17? Oh, wow. We're getting a couple of 17s here, guys. Wow. Look at these. 17, 17.5, 17.49, 18. Okay. Okay. That's interesting. But it seems it only saves the one that beat the, I mean, it depends on the range of our data. No, Yassine, right now it's saved everything. We haven't asked ChatGPT to create any sort of ranking or anything like that. But we got a couple of 17s, which is nice. Denelson says, I like it because now we have a general baseline. Yeah, Denelson, I love your outlook on this, right? Because we didn't know before. But now, guess what? We've learned something. Our experiment taught us something, right? So this is great. It's great for our knowledge, right? For our process. Ruben says, might be interesting to know what the MSC of the model is without hyperparameters enabled. Well, you can't have no hyperparameters, Ruben. You got to have some. And as we saw before, some of them have default values. They're going to be used no matter what. So, Ruben, that's not possible. Hyperparameters, they always have some value. Just because you don't set them doesn't mean that there isn't a value being used, right? Sim says, do you have a spreadsheet software so you can quickly check the min or max for that column? Yeah, I do. And you're right. We should be doing that. But this is just our initial run, right? We're just learning here. The likelihood of us finding like a champion model today is like not high, right? So let's just, take it one step at a time, right? 265, 18s. Okay, but coming back to the root question though, right? Is anybody excited by that value? Even if the value is like 17, right? 18. Does that sound good for financial investments? I'm not excited about it. What do you guys think? Yassine says, yes, I mean it doesn't. Yeah, Yassine, because we haven't given that instruction yet, right? We haven't asked ChatGPT to be informed about that yet, right? So we'll get there. We'll get there. Yeah, but I think 17 is about the lowest I've seen. Couple of 18s. RC Sim says, I wouldn't invest even if it was 0. But RC Sim, that if it's 0, you found the world's greatest algorithm though, right? That means that whatever your algorithm says is exactly what happens the next day. Like, that would be awesome, right? Oh, yeah, nice catch. Nice catch. There's a 14 there, Denelson. Denelson says 14, line 4, yeah, good catch. So there's a 14 there. Nice. Yeah. And remember, guys, we only did 2 values for each of the hyperparameters, 2 to the 10th. We could have done a lot more. We cut out those values, right? For processing time and speed, right? So there's a long ways to go here, right? But we're more informed, and that's the win, right? Not every experiment's gonna result in something amazing, but you learn. To Dennelson's point, we now have a baseline to work from. So let's develop this further. One, we can go to ChatGPT and say, from now on, I want you to only tell me about the models that beat each other in the baseline, right? Run the model, hold that baseline, and now only save the ones that are better than that. That's possible. But what if we said, hey, here's the baseline that we're at right now, and now I only want you to show me the models that are better than that baseline. That's a much better way to go about it, right? Because now we can say, hey, look, I already know how to get 14 for my MSE. So now only show me these that can beat that 14. That's pretty good, right? Because now you run that experiment, and now you can say, okay, yeah, I'm progressing. I'm doing I'm moving forward here, right? And you build on that knowledge. You use previous experiments to inform other experiments. And then you can save those models. And now that model becomes something you can use in your prediction code, right? Because you're going to instantiate that model, and then you're going to go ahead and use it. Or we can visualize it, right? Like now we're getting to stuff that's pretty cool, right? So, RC Sim says, I just assume the algorithm is wrong or something makes it too risky to bet money on it. Okay. I can understand that people have different tolerance levels for risk. I get it. You know, I used to work in, investments and all that. But there's also something to be said for having confidence in your work, right? Like, if you work hard at it and you come up with an algorithm, then why not trust it, right? But you guys let me know. Like, wouldn't you trust your own algorithm that you wrote? Like, I would. I have in the past, right? Like, I use algorithms for my own things. So, like, why wouldn't you do the same? Like, you gotta trust your work at some point, right? So let me know what you think about that. Okay, so let's go back to ChatGPT and let's start making some modifications, right? But also, guys, remember, to ChatGPT's credit, I mentioned to you earlier how this is the longest piece of code it's written for us. It did pretty well. We got an error because I didn't have scikit-learn installed, which I'm really surprised at. And the second error was around, my own, pathing to the data folder, right? So, but the code itself for ChatGPT, it basically did what we were hoping for, right? So let's make a change. We're going to ask for two things. We're gonna give it a baseline to start from, and always and then we're gonna ask it in the CSV to only add the ones that beat the baseline, and also to create a visualization of that result. All right, so let's do that. Okay, I wrote this poorly. Once the code is running in the CSV file, I only want to log the hyperparameters that beat the baseline. When the model beats the baseline, set that MSE as a new baseline to compare against, and also create a plot that shows the results for the new model with the model with the new baseline MSE. All right, I think this should get us there. You can set initial baseline MSE in the main function, selective logging, dynamic baseline update, yep, dynamic plotting. Okay. Still writing the code out, so I'm gonna wait till that finishes because I've copied it too early in the past and that's not good. Oh, it's going to show me the plot, which is not ideal because that means the plots will come. Well, you know what? Let's go ahead and do that. Okay, let's copy this code and we're going to put it into our Visual Studio Code. So here you can see that we are using, there's an initial baseline MSE value that is also now passed to our stock price forecaster class. So let's go ahead and set this at 15. Because we know we're getting some values that are lower than that, right? Let's go ahead and do that. 15.0. And the part that was kind of jamming me up here is that it's going to show us the plot every single time there is a new baseline value. And that's okay for now. Because and the reason why I'm hesitant is because when that plot pops up, the terminal stops running. The terminal takes a pause, just the way that it's done on a Mac and all that. I would rather have it just save the plots and then we can come back to them and look at them later. But this way we can kind of look at them in runtime and that's okay, right? We can stop when necessary because we probably won't do the whole run again. We just kind of need to get a feel for what those plots look like, right? So let me go ahead and we need to adjust the paths too, right? Because I didn't ask ChatGPT to fix that. Oh, right. This I want here, and then we need to adjust the values. We'll go ahead and do the same strategy we did before, where we'll just keep the highs and the lows, only because I want to cut down on the number of combinations, right? If we ran all these permutations, it would take forever, right? Do this. Okay, I think everything looks good. Yeah. We're going to go ahead and save that. There's an extra space. No. And we shouldn't. Yeah. Okay. So the scikit-learn import went away. Okay. So we're not going to get a plot for a while, right? Because we know that early on we were getting some very high values. But let's see what happens. Yeah, so we're still getting those high 34 values. I think it was line 475, right? So It's going to be a little bit here until we get down there. I'm still seeing 34s, 34s. So we're going to see some plots along the way. And then we're also going to see a much smaller CSV file, right? Because now we're only saving the better models or the better results. So our CSV should be severely shorter than it was before. Let me go check the chat. I don't have my chat up. Leo says it's not betting money. Yeah, Leo, you're right. If you achieve 0 MSC, it's not betting money. Like you were literally predicting the future, right? RC Sim says, I could trust my own code in general when I test it thoroughly and trust the data it depends on. This kind of analysis is new enough to me that I wouldn't trust it with a bunch of investments. But you got to start somewhere, right? You got to start somewhere. But, you know, like I said, I respect that people have different tolerance levels. I get it. Denelson says, I say we should save them too because it might close the previous plot and we'd lose the visualization. Yeah, Denelson, you're right about that. That is another concern. Oh, yeah, Leo, sorry about that. Leo said, Dennis, what about checking the R squared and R MSC? Yeah, sorry, Leo. I did see that before. I apologize. So, Leo, here's the thing. Okay. Oh, wow. Okay, guys, so sorry, Leo, let me come back to that. We have our first plot. So as I said, guys, this is my concern, that when the plot comes up, the processing stops. But this is saying that, ooh, 13.66, guys. So even lower than what we saw before. So this has an MSE of 13.66. What do you guys think? It didn't show us the band, which I'm a little disappointed in. But what do you guys think? If you need me to zoom that or whatever, let me know. But give me some feedback in the chat. This is a 13.66 MSE. So what do you think, Sim? Are you investing your money here? Or Leo? Leo and Sim, you guys seem to have different risk tolerances. Are you investing your money here? Or to Matt's earlier comment, it's the same spikes as before, right? Because the ground truth never changed, right? But the yellow line here is the forecast, what you thought was going to happen. What do you guys think? Leo says, well, pretty good. Okay. Yassine says, I think it's great. Okay. Ruben says, we picked a baseline with a small MSC. Wouldn't you be concerned with the model overfitting? Leo says, yes, I would invest. Can you zoom a little more? Okay. Let me see if I can do that. I think I can. Oh. Here we go. Let me look, Denelson. Okay, it says zoom to rectangle. Let me see if I can do something here. There it goes. All right, is that better for you, Denelson? What do you guys think? Manoj says it's good. Starry Vibe says it's good. Did we include the prediction window length as a hyperparameter? That's a good question, AJ. I don't think we have. I don't think we had. Denelson says it's a good model, better than the previous forecast. Okay, so let me come back to Ruben's question. We picked a baseline with a small MSE. Wouldn't you be concerned with the model overfitting? So we should always be concerned about overfitting for sure, right? But two things come to mind here, Ruben. One, we picked the baseline to be low, but it was an informed decision, right? We took an informed decision to say, hey, look, we're just going to take the upper and bottom, see what happens, and we know that we can achieve 14. And we know that there were some, this is a 13. But we knew there were 14s, 15s, right? We knew we were in that range. So it's not like we're picking it randomly and we happen to hit across an overfit model. This is an informed decision, right? The second thing that comes to mind about that is that you're supposed to converge on a model at some point. And 13 as an MSC is a great value for like an investment and stuff, but it's really not all that low when the perfectly fit model is a 0, right? So I hear you, overfitting is a concern, but I think that we're still, exploratory enough and far away enough from 0 that we're okay to continue here. I don't think that we're really in that danger of overfitting yet, right? Matt says, how would I know if this would be a good enough to trust for investment? The line is sometimes above the actual, sometimes below. Well, Matt, one, it depends on your own tolerance. But two, what does mean square error mean? It's the mean of the square value of how much these errors happened, whether they were above and below, right? So it also kind of speaks to the range that you could expect. Because that MSC could, we know our MSC value of 13. So you could be 13 above or 13 to the bottom on average, right? So is that range something that's acceptable to you, tolerable to you? Another way to look at it is to say, well, look, we're very early in our grid search. We're very early in our champion model search. We know that we've picked polarized values, right? We're doing that for speed, right? Maybe you would say, well, if I can get to an MSC below 10, then I'm more comfortable with investing. Does that seem like we can achieve that with that model? Yeah, that's a reasonable expectation. Not a guarantee, right? Not a guarantee. But if we're this early on and we know we're using polarized values, we're only doing 2 to the 10th searches when we could be doing a lot more, maybe you'll reach a range where you'll be more comfortable with it, right? So it just depends, Matt. There's a lot of elements to it, right? There is no single answer there. Tej says, hey Tej, good to see you again. Hey Dennis, how many days in advance does the model predict for? Yeah, good idea, Tej. A good question, and it ties back to AJ's question about the prediction window. And I don't believe that is a hyperparameter, and I believe it's 3. Give me just a second. Because our original code had it as 3. Yeah, it's 7. It's 7 days or 7 periods, which in our case is a day, right? But yeah, it's 7. So to AJ and Tej's point, we could also change that to be a hyperparameter. Now, in case you're confused, that's referring to if I take the data and I take the analysis, how many days in the future do you want me to make the prediction for? And in this case, we've hard-coded 7. But it could be other values, right? It could be 2 days, 3 days, 25 days, whatever you want. But yeah, that is something else we can fine tune. But for the purposes of instruction, kind of keep this going, I focus on the more direct hyperparameters. But yes, Tej and AJ are right. We could also be tuning the forward-looking periods for the model itself. And we'll do that, right? We can get to that iteration. All right. So that means that we now have our first entry in the CSV file. So here's where it kind of gets a little exciting, right? Because this is our latest result. This was what, 13.6, I think is what it was. And some of you said, hey, that looks great, right? So I'm going to close this out. It's going to make our terminal restart again, right? You can see the terminal going again. So now, anything that pops up is going to be better than 13.6. Right? Okay, and it just finished. It just finished, and there were no additional views, which is interesting. But that's where it kind of gets exciting, because now like I said, it's king of the hill, right? Who can top that? Who can top that king of the hill value? So that's where it kind of gets interesting, because now it's like, well, wait a minute. Now we're waiting for something that's less than 13. That's pretty cool, right? So if we go to our CSV file, we should only have one value now. Yep, we only have one value. So this should illustrate to you a little bit more about where we're at. So we know that the growth should be linear, not logistic. The change point, the seasonality mode, we know that these values are pretty good. We know that if we use these values, we're going to get to a pretty good result. Well, we know we're going to get to about a 13.66 with these values. So Denelson, coming back to your question, now you can make the case, to cut down on that processing time. You can make the case to say, okay, from now on, we're only trying linear values. Or from now on, all of these values, we're always going to set them to true. We're going to hard code those, but now we're going to add more ranges to the other values. Now we're not going to be so polarized. We're going to pick the middle value. And now we're going to see what that does, and so on, right? So let's do that. Let's do that as our next run. Sonali says, I am from India. Nice, Sonali, welcome. I think it's your first time, so welcome. Thanks for joining us. So we're going to set all of these values to true. We're always going to do linear, and we're always going to do multiplicative. So let's do that, right? Because that will open us up to change more values in the numerical sections, right? So we're going to say all of these are always going to be true. We're always going to use linear, we said. And we're always going to use multiplicative, right? So now what we can do is start picking some of the middle values. So here, let's pick 0.25. Oh, come on, Dennis. 0.25. We're going to pick 5. 5 again. 0.5. And 25. Right? So we're going to keep the same baseline to start with. It's completely reasonable for us to get the results, get the same results again, 13.66. And we have a non-zero probability that we're going to get something lower than the 13.66 because we've expanded our search range, right? So I'm excited. I think this is great. AJ, I see your suggestions, but let's take it one step at a time, okay? One step at a time. All right. So yeah, I think we're good to go with this code here. $34, $258, $258 again. So we're still getting some of those really polarized values. Whoa, 8582 is one of the values that I just saw come across. 8,582. That is a really high value. I think that this should be less iterations than what we ran before, or permutations rather. Tej says, is there a way to plot the predictions? Tej, that's what we were looking at earlier, right? The blue line was the ground truth and the orange was the predictions. We already looked at that. And we should see it again, right? Because we have the same combination of values that are, there we go. So there's our first one. So we got a 13.99, guys. So slightly worse than our previous model, but 13.99. So Tej, to answer your question, the orange line is the predictions. The dashed orange line is the predictions. Okay? What do you guys think? I mean, to me, it doesn't look all that terrible. Pretty similar to the previous one, right? I mean, it'd be kind of hard to tell by eye that you can see the difference between 13.9 and 13.6, right? But that's not a terrible model. Anybody else want to give their opinion on it? Because otherwise, we'll just keep running. Because we should come up with more plots this time, right? Well, at least the ones that beat 13.99, right? So let's keep going. I'm going to close this out. That restarts my terminal. All right, we got another one. This is our lowest one yet, guys, 13.3. What do you think? Again, maybe you can't tell by eye, but you know, some of you out there sound a little hesitant, or you know, you have a different profile risk. But maybe at sub 13 you feel better. A sub 13 MSE you would feel better, right? Or maybe like at a sub 10 MSE, we'll say, hey, I can see an actual visual difference in this chart, right? Like at some point you will start to see a much closer relationship between the predicted and the actual values, right? They'll start to converge on each other. That's kind of like the whole point of a lower MSE, right? Or, you know, something else that's jumping out at me, Matt. You know, Matt previously asked about the spikes, right? Look at this one, Matt. Look at that orange line. That orange line is not so bad to that spike, right? If we go back to our previous chart, look at that, guys. This was our previous model from last week. Look how far the prediction is from the peak of that spike. And look how much closer you are when your MSE is 13.3. Look at that. So Matt, to kind of, answer your previous concern, the lower the MSE, the more we'll approach those spikes, right? And if your model predicts the spike, then it's not so much of a spike anymore because you knew about it. Your model told you about it, right? So I think that's pretty interesting, right? I mean, it's quite a difference. Or even on this spike, right? Oh, wow, look at this. Here in this model, it almost perfectly matches the spike. Whereas in last week's model, you would have totally missed it, right? Tej says, well, no, Tej, that's not 100% correct. The line is showing you what the forecast is for that period. Right? So it's making the forecast without the actual data. It's already telling you that, right? So the lines are kind of out of sequence, right? I can't remember what the term is. I think it's a time shift, right? So the lines already have a time shift built into them by 7 days because that's the period we've chosen. So your concern is already reflected in the blue line. All right, so let's keep going. Let's let this keep running. So just to kind of reinforce what we were doing earlier before, what we were talking about before in the slides, right? So now our new baseline is 13.3. Our terminal is going to run, and it's going to try to beat that baseline. So now anything that pops up will be lower than 13.3. And so, okay, we're done. So that means that in our CSV, we're only going to have two values. We're going to have the 13.3 and what was it, the 13.6 or something like that we had earlier. So that's my expectation. And yeah, there it is, right? Okay, it was a 13.99, 13.99 and 13.32. And you can see here that there was a difference in the change point prior scale, right? They're not using the same value there. Are the values the same for everything else? They are. Okay, very cool. So this indicates that the change point prior scale might be a hyperparameter that we want to add more values to, right? So Denelson, again, coming back to your question, we're converging, right? So this is indicating that the higher end of the change point prior scale values might be more beneficial to us, right? So there is an argument to, let's go look at what that looks like. Let's take a look at that. Change point prior scale. So there's an argument to be said that the answer would lie somewhere above 0.25, possibly near 0.5, but it could also be higher than 0.5. And maybe there's an argument to say we can throw out the bottom end. Right? So let's consider that. So let's try 0.6, 0.75, and 0.9. Right? You guys on board with that? Are you guys seeing how I'm coming up with that type of deduction? I mean, we got some pretty good I mean, as far as MSEs goes, that's more than a half point drop by going from 0.25 to 0.5. Like there might be something there, right? And we continue this process over and over again, just trying to get to a better result. So let's try it. You know, to Tej's earlier point, we could be improving on the plotting, right? Oh, okay. So no surprise, we got the 13.99 again, right? We should expect that because we haven't changed the changes to the permutations that we made still include the previous settings. So the fact that we got the 13.99 again, not a surprise, right? We should also get the 13.3 again unless we hit on something else that's lower than that prior to that, right? You just don't know. But we could be doing a better job on the plotting in order for us to... Okay, so here's the other one. 13.32. Oops, sorry. So basically the same chart that we saw before, right? So right now we're basically getting the same results that we got before, which is expected because those permutations are still part of our grid search. Let's keep going. Hopefully we'll get another chart. And if we do, that's good, right? Because that means it'll be lower than 13.3 and so on and so on. Oh, wow. Are we coming up on 3 hours or 2 hours? Can somebody tell me that? I've lost track here. I think we're coming up on 3 hours. Oh, no. Oh, no. Sorry, guys. I just spilled my water on my mouse pad. On my trackpad, I should say. Give me just a second, guys. Here, let me move that chart. We got another chart, guys. We're at 13.2. Oh, wow. Look how closely it tracks those spikes. So, Matt, how do you feel about those spikes now? I mean, if I was in your position, I'd feel a lot less concerned about them, right? Like, your concern should be alleviated with a model like this, yeah? What do you think? What do you guys think? 13.26. Oh man, I spilled this all over my desk, all over my trackpad. I'm seeing your comments in the chat, guys. I will get to them as soon as I finish drawing things as best I can. It's spilled all over my trackpad, and a Mac is impossible to use without a trackpad. All right, so Denelson says 3 hours. Wow, that's crazy. Thanks, Denelson. Appreciate that. Okay, Matt says, I'm loving the spikes, but now I'm confused at the process of adjusting the hyperparameters. How would we know if we just hit a local minimum for a hyperparameter versus the actual minimum for one if we just keep guessing values? Well, we're not guessing values though, right? We're making informed decisions at every step. It feels like we're guessing values, right? But I mean, one, grid search, a proper grid search. I mean, let me take a step back. Realize that we're modifying our grid search a little bit because, you know, just for the speed of things, right? I don't want us to just sit here and see it run and run and run with no action, right? So I am, you know, I am kind of fudging the numbers in that sense. But in a pure grid search, we would just pick every single value and go, right? Just let it run for days and days if needed, right? So that's really no different than what we're doing. We're just informing our decisions a little bit more. And we're doing combinations that would be tried anyways in a big grid search, right? Like, we're still in the same range of values. We're still trying different things. So it feels a little bit more reckless than it actually is. I'm just kind of trying to shortcut things for us to get there. But these values would be tried anyways in a proper big multi-day grid search. So Matt, to your point, this is why I told you guys that this is the same argument that the anti-data scientists say, right? Well, you're just trying everything. There's no magic to it. Yeah, grid search is a little bit of a brute force search. I get it. I see the side of their argument, right? I mean, if you think about it long enough, it might make you quit data science, right? Because it is kind of a strong argument. So I know it feels a little fudgy, Matt, but we would have come across this anyways in a proper grid search. We could probably find something even lower than this. We just haven't done enough of the searches, right? So this is the data science side of it, right? I mean, this is why hyperparameter searches exist. So if it feels a little dirty, I get it, but this is the work. So 13.2 is our lowest one yet. Let's keep going, right? There could be more. RC Sim says, I spilled something on my laptop. Yeah, fortunately, this is not my laptop. I do have a proper desktop, but I don't use a mouse. I use the Apple trackpad. But yeah, I definitely don't want to lose my trackpad functionality. Okay, guys, 13.01. 13.1 now. Look how closely that tracks those spikes. Look at that. 13.1 MSC. So in other words, there is good reason to believe that we can go sub 13, right? I'm optimistic we could go sub 10 because, again, we're only searching a small fraction of all the possible values, right? Tej says, I'm curious to know what the predicted values for the next 7 days are. But you're seeing them in the line there. The orange line is the prediction for the next 7 days. Remember, it's time shifted, right? So the orange line is the prediction for 7 days. So Tej, maybe I'm just not understanding your question, but it's the same answer as before. When you see orange on down here on 1/2024, the orange line represents the prediction that was made without the previous 7 days worth of data. In other words, 7 days ago, right? That's the time shift that that Prophet is doing underneath the hood. AJ says, the next time the anti-DS people bring up that point, I'm going to say, go look up random search, Bayesian optimization, genetic algorithms, and gradient-based optimizations. Okay. That's one way to go about it, sure. But again, I'm presenting that to you guys. I mean, obviously I'm pro data science, right? I mean, I love this stuff. But I'm presenting that to you guys to, because nobody tells you about this. Right? Your professor is not going to tell you what the anti-data science argument is, right? You come to your good friend Dennis for that, right? So that's why I'm bringing it up. But I hear you, AJ. I hear you. All right. So 13.05, guys. And you know what? We still have more permutations to go. So let's close this out and let it keep running. Yassine says, I think what Tejar wants are the predictions for the days that we don't have the actual data for. Just the number. Okay, let me come back to that, Tej. Okay, guys, so we're sub 13. 12.7. That is a 0.4 drop in the MSE. That's pretty big, guys. 13.1 to 12.7. Is anybody investing now? I think it was RC Sim. RC Sim, how's your money looking now? Are you investing? Or are you still out? Or Leo, you must be loving this, right? You were willing to invest at 13.6. So I mean, this is almost a full point improvement from what our initial baseline was, right? RC Sim says still out. Okay. But guys, again, you know, I joke around about the investments and all that, right? The point is, though, that we are continually informing our opinion, right? We are continually headed in a direction that says, well, wait a minute, this shows improvement. That experiment went well. That experiment didn't go so well. What can we improve about this, right? I hope you guys are seeing that, right? That there's a lot of things that you can sit here and look at and say, oh, okay, yeah. Like this is the experimentation side of data science, right? This is the experimentation of what we do in the lab, right? Like this is our, like, you know, we're not chemists or physicists that work with physical things, but this is our lab, right? Denelson says, I'll double my investment. Okay, cool. I love the confidence, Denelson. RC Sim says the predictions look very accurate. It looks like the software is working well. It looks like we're headed in a good direction, right? I mean, that's because you're right. I mean, if this was your model, you would say that. But I'm thinking about it in terms of like just our overall model experimentation, interpreting results, right? This loop that we've been talking about, right? This loop is headed in a positive direction, right? Like I said, we're only testing a small portion of the permutations, but is it crazy to say that we're headed towards something that's a sub 10 MSE? No, we probably are headed in a direction like that, right? Could we include the predicted data for the next prediction window? I'm going to invest $1 Monday morning based on this prediction. That's funny. I think you need more than just $1 to invest in Microsoft, my friend. But the point is that, you know, we're headed in a good direction, right? We all agreed that the ideal value for MSE is 0. 0 itself is probably not achievable, but we're trending in that downward direction, approaching 0, right? That's a positive thing for us. AJ says fractional shares to the rest. Okay, I don't get involved in that stuff, but you're right. There are a lot of fractional offerings out there. Okay, so let's keep going, right? Our current sim has not finished yet, or our current grid search is not finished yet, right? Whatever pops up next should be lower than the 12.7, right? Okay, so we're done, and 12.7 was our champion model, right? So if we go back to our Visual Studio Code, there it is, 12.71. So now that becomes our new baseline, right? Anything else we want to do from now on? Because, you know, some of you were mentioning earlier, oh, well, we need more values, or maybe we should try another time series or other methods, right? Now our new comparison is 12.772, right? Because we know we can get 12.72 by this method, I should say, to not confuse things. So this becomes our new goal, right? 2020 EAFC, yes, I am replying to messages, of course. Matt says, I work as a strategy manager and the idea of constructing a model of the future is the dream. You can get there with this, right? Now, this is time series data, but Matt, we can definitely talk about that, right? Because what is the timelines you're looking at? What are the factors that you have available? It's the same process, the same methodology, right? The methodology that I display here holds for any data, any project you want. How you apply that and what techniques you use, that's the creativity and the skill of a data scientist. But you can achieve the same thing, Matt. You can absolutely achieve the same thing. RC Sim says, I wonder if this could find patterns, historical weather data to the point of predicting it a day or two away without hard coding of meteorology or physics. Sure. Yeah, that's a good question now that I think about it. Because remember that one of the challenges with Prophet is that Prophet only uses 2 inputs. Give me the date and give me the value. That's all it knows, it's all it cares about, right? So you'd have to find some sort of numerical representation that you wanted to work with there, RC Sim. Are you going to use the weather, the barometric pressure? Are you going to have like a mini model that creates that value, right? Like a pre-processing mini model? You might want to do that. Like maybe you would come up with like a categorization algorithm that picks one of 10 categories of the day. And those categories are fed by temperature, barometric pressure, elevation, and air quality. That gives you one of 10 values that you then use, that you then put into Prophet, and then Prophet would tell you what the next day is going to be, what value of the 10 it's going to be, and then you can interpret that to what the day is going to be, right? So that's off the top of my head, obviously, but I think you can get there with something like this. Yeah, you could do that. Because Prophet looks for those patterns of how the days or of how your values in the time series are happening, right? But you could get there. You could absolutely get there. Ruben says, what if you made a prediction for the next 7 days, tomorrow, the day, and the next Sunday, we should see how the model performs? Yeah, we could do that, sure. But right now, I'm really more interested in showing you guys the pattern. Because look, I don't want to sit here and run sims for you guys. I want to enable you to run your own sims, right? Like I appreciate RC Sim's question because they're thinking about it on a meta level, right? How can I take this and use it for other things in the future, right? Or other data, other patterns that I'm interested in that fit more my needs. Because not everybody's interested in investing. It's just convenient for us here because there's a lot of data for it, right? But yeah, Ruben, I hear you. That would be fun to do, but I hope you guys are walking away with the greater framework than you are the stock information, right? At least that's my hope. So, all right, guys. So here's a closing thought that I want you to think about. Okay. What about our other model, our other idea? Our other idea is the efficient frontier theory, right? Manoj, I don't know if you're still in the chat, but that was Manoj's idea. And we did a lot of work with that last week. A lot of really cool work, right? What about that? We already said it's a lazy loader, so there's nothing to fit. We already know that it's not for individual investments, it's for a portfolio. And because it's a lazy loader, it also might take potentially more time to process, right? Because it's all runtime code. What about that? We haven't spent any time today talking about what those experiments look like. Where are we headed with that? It feels like we're going to have to write more code, right? More native code to do that. Because here, like, there's hyperparameter things that we can do that are really convenient. But on a lazy loader, you're not going to have that. Right? That's kind of one of the downsides of a lazy loader. So what do you guys think about that? EAFC, of course I'm replying to messages. Feel free to ask us something in the chat, okay? Feel free to join us on YouTube too if you'd like. Lawman, hey, I don't think you said hello earlier. How are you, my friend? Hey, Dennis, I feel like a kid who is stuck doing homework while he looks at his friends playing when I see your Sunday life. Oh, that's hilarious. I love it. I love that comment. Okay, someone, well, let me finish out Lawman. Lawman says, I want to ask, does customer churn prediction also follow a similar framework? Ooh, that's a really good question. Yes, you could use this for that, but here's the caveat. You won't know why. But yes, if you wanted to say, I'm going to maintain a data set where day by day, I know how many customers left me, how many customers joined, whatever, right? Whatever you define as churn. Can I predict what next week's churn is going to be? Yes, you can, Lawman, but this model wouldn't tell you why. And that would be important in that type of scenario, right? In stocks, you don't care, right? You usually just care that you made money, right? If the model says Microsoft's going to go up $10 tomorrow and it does go up, you're just happy, right? You don't care why, right? You can say, well, because it has a low MSC. Yeah, but that doesn't tell you why. And you wouldn't care. With your question, you could get to a good model, but you won't know why. It'll just be a black box to you, and that may not be ideal for customer churn. But again, you tell me, because it depends on how you're defining customer churn. I'm making some assumptions on why you would need that, but maybe I'm wrong. But you could get there, just completely unexplainable, and that's usually undesirable. Okay. Manoj says, yes, sir, I'm here. Okay, cool. So Manoj is here. So Manoj, I love that you suggested the efficient frontier. I think we saw some really cool visualizations last week, right? With some really nice charts. I think we have some pretty good code. But how are we going to experiment with that? Don't get me wrong. I'm not saying it's impossible, and I have some ideas, obviously. But, just kind of thinking about it out loud. It seems like it's going to be a little bit harder, no? Maybe easier, maybe harder, maybe slower, maybe faster. I could kind of see it both ways, right? What do you guys think? Let me know in the chat. Because we focused exclusively on time series today, but next week we're going to do a similar session, but just for the lazy loader, the efficient frontier. So think ahead to that. What is that testing and permutations and hyperparameters and all that look like? I don't know. I don't know what that looks like. And then think about this one, right? Think about what we just finished. We talked about treating the periods predicted as a hyperparameter. That's a good idea. What about more data? We said from the beginning we're only working with a year's worth of data. Is that enough? Maybe, maybe not. What if we bring in 2 years of data and all of a sudden we can't get back to that sub 13 MSE? That could happen, right? Maybe more data kills the model. That's possible. More data is not always the answer, right? So what happens then? What do you do then? Or maybe it'll drop in a significant way. We can get to sub 5 MSE because we're using 2 years of data. That's possible too. So there's a couple things here that we can still fix. We also haven't saved a fit model. We haven't used a prediction model, right? So those are the things to try, right? Vishal says, evening, sir. Vishal, good to see you again. I think you've been here before. Pretty sure you've been here before. So glad to see you. Hope you're doing well out there in India. Manoj says, maybe portfolio optimization techniques. Maybe, maybe not though, right? And then how do you define a portfolio technique? How do you keep track of all those portfolios? Right? So lots to think about there, Manoj, and everybody else in the chat, right? So next week, we're going to do a very similar session to this. with me? Why did my phone just beep? That was weird. My camera just beep. You get my video's still on, right? You guys can still see me? So give me some feedback in case my camera went off. But think about that, guys, right? We're going to do the same thing in theory, but the code and the way we're going to go about it is completely different. Completely different. Okay, thanks for the feedback there, guys. My phone camera made a noise, and it's never ever done that in like 6 months of streaming. That was weird. Maybe I'm hitting some sort of limit or something because we have gone a while now. But thanks for the feedback, guys. So think about that, guys. What happens when we're using a lazy loader or a portfolio? How do you design experiments for that? I've never done it before. I have some ideas, but we're gonna work through it together, right? So guys, what a session. What a session. Lots of stuff covered today. And again, my biggest hope for all of you guys is to take away the greater understanding of what it means to run data experiments, right? Because this is the work of a data scientist. Today, we spent time in a data science lab, right? We may not have used beakers and other physics tools and things, but we use the data, and that's the tool of data science, right? So I hope that you guys are seeing that bigger picture. Because again, I'm not trying to tell you to invest in Microsoft stock. I'm telling you, this is how we do these different experiments. And I'm also showing you some of those counter arguments that we talked about for data science. Why some people would say, well, data science isn't really that great. It's important for you to be informed on both sides of the argument, right? That's what an intelligent person does, right? But lots of really good stuff today. I want to thank all of you for all of the great participation, all of the great feedback. I'm just really happy that this session could come together because it's really this is the core of what a data scientist does, right? Rex is crying because he can't turn your script into a podcast on Google's notebook. I think he already has. He already showed me one that's very close to that. Leo says, good job, Dennis. You rock it. Thank you, Leo. Appreciate that feedback. So I hope you guys got a lot out of this session. It was a lot of fun to put together. We're going to do something similar next week, but completely different code, completely different approach. So I look forward to seeing you guys there. Some of you stuck with me for the whole 3 hours. I don't know how you guys do it. Thank you so much for that. RC Sim says, thanks, Dennis. It's very educational. I hope to apply some of these techniques on my own soon. Yeah, great. Look for your own applications, guys, right? Look for your own uses, right? That's kind of the whole purpose here, right? So, Matt, it sounds like you were also developing some ideas ahead of time of what it could look like for some of your thoughts. So good for you. Lalman, same for you when you asked about the customer churn. But anyways, guys, thank you so much for sticking with me the whole time. As always, there's a lot of nonsense happening in our world. So please take care of yourselves, take care of your families, and I'll see you guys next time. 100K celebration coming up sometime this week. So stay tuned for that. Thanks, everybody.